Okay, you're live.
Thanks, David. Welcome everyone to this workshop. This is a Hyperledger Foundation workshop named Operate and Extend Hyperledger Besu. A little reminder what we're going to go over today. If you have the chance to stamp this link here on the wiki, you'll see a copy of this content as well. So we have 2 sessions of 2 hours today. So a lot of meaty content, and this is the first time for me doing it. So please, bring your feedback and be honest with me. If I bore you to death, I need to hear from you, and also bring your questions, bring your interrogations about what the project does and all those things. And so for these 2 first hours, just to focus a little bit on the immediate, we'll first talk about what Besu is, where it's coming from, what it's trying to be, where its aspirations are. We'll spend a little bit on how to configure it, how to actually run it correctly, all the gotchas, all the things that you need to know when you're about to operate Besu. And then we'll go deep into actually running Besu ourselves on our machines. So we have some different exercises here, from running it in a simple dev mode to working on our own Genesis block, to then actually work on a consortium. So that's it for the operation session. Before we continue, I have a public announcement. Oh, sorry. We have some prerequisites as well on the workshop that you can check out on the wiki. If you haven't done so, please do so ASAP, so you have all the resources available to you, so you can participate and follow along the workshop. Now, for a public announcement from Matt. Matt, take us away.
Yeah, thanks for the tee up there. So my name is Matt Nelson. I'm a product manager around Hyperledger Besu for Consensus. And we are in the spirit of this workshop. We're looking to set up a bunch of new education sessions to kind of talk about some of the future of what we're seeing with Besu and public networks. So, again, what do you want to learn about this topic? What do you have as far as questions around public networks, the merge, proof of stake, how Besu is planning to evolve for these, functional pieces. And, we want to get direct feedback on what you might see if you're already familiar with Besu. And, this is just a refresher. So we'd love for you to take this quick survey. There's only 7 questions. It's very quick. Some are multiple choice, some are write-in. So feel free, if you use Besu, or if you don't use Besu and you're looking to get more familiar, or if you're looking to shape the future of our software. It is, of course, open source. We're always looking for contributors and feedback. Please help us out with this survey. It would be tremendously helpful. And it'll also help determine what education sessions and workshops we run in the future through Hyperledger Foundation. So if there's anything that you'd love to see covered around Besu, or even Ethereum, staking, any general questions around public networks or around, the future of Besu, give us a shout in that survey. We would love to see your responses. It's super quick. And I think David will also send out the link. It's in the slides, but David, maybe you could paste in the chat now, and it is pasted in the chat.
Yeah, I just posted in the chat. I'll also send an email out to everybody who had registered as well. So you can look in your email for that, or just click on the link in the Zoom chat.
Yeah, thanks so much. We'd really appreciate it. You can also email me directly if you have candid feedback. It's mattnelson@consensus.net, or matt.nelson@consensus.net. So please feel free to help us with the survey. We look forward to hearing from you all, and I hope that you enjoy the rest of the workshop, learning about Besu.
Thanks, Matt. I really appreciate you taking the time and telling us a little bit about what you're trying to achieve. And I think this survey is critical to Besu and its success as an open source project. So thank you so much for taking the time to explain a little bit what you're trying to achieve in terms of understanding. And please all take this survey. That's the best outcome from this workshop, is that you take a minute and you fill the survey so we can understand better how to serve you as a community, me included. David, would you like to go over the rules of engagement before I move on?
Sure. So as people are probably aware, Hyperledger Foundation runs a number of open source projects, Besu being one of them. As an open source project, we welcome everybody to get involved. As the name suggests, we're open if you want to join our community events such as this, or the regular calls that Besu runs to talk about the development work on the project, or if you want to join any of our channels, as I said earlier, we have a Discord chat server, we have mailing list, everything is open. You're welcome to get involved. No invitation needed, no requirements about getting involved. Anybody who's interested is welcome to do so. The only really ask that we have for people is they just, treat people well, basically. We have a code of conduct that lists, what we expect in terms of, how people treat each other, and it's just basically be civil to everybody. So the same applies here. We welcome any questions, comments, feedback, suggestions, any discussion that you would like to have. Again, just we ask that you be civil when you do so. And then speaking of different community channels, I know I had said this earlier when people were starting to join, but I'll say it again. You are, able to ask questions in Zoom chat, but we would encourage you to use the Besu Workshop channel on the Hyperledger Discord server. There's a couple of reasons for that. This Zoom chat channel will obviously go away when the workshop's over, but that Besu Workshop channel is permanent. That's something, if you have questions about Besu after this workshop, that Discord channel is a good place to go. It will also put you in touch with other people in the community who aren't able to join this call. So I did just drop a link to the Hyperledger Discord server in the Zoom chat. Again, you are welcome to ask questions in Zoom if you want, but we encourage you to go to the Besu Workshop channel on the Discord server. And if you have questions about how to get on the Discord server, you can put that in the Zoom chat, and I'm happy to help.
Thank you so much, David. And we'll remind you throughout, there's such a thing as this Discord channel. If you have any questions, I personally will welcome any questions as we go, because I want this to be a lively exchange, not a dry set of slides that you could just read at home. I kept the content of the slides minimal, so I can actually entertain you with my voice, which may at times not be intelligible because of my French accent. Now, I recognize that. And I understand that people have different types of ears. So if you don't understand what I'm saying, make me repeat. Don't feel bad about it. And with that, let me take you a little bit about me. I work at Splunk, which explains the really wonky background and the fact that there's a toaster next to my picture. I'm the senior engineering manager for the blockchain team at Splunk. I've been at Splunk for over 2 years. Previously, in a past life, I worked at Consensus, just like Matt, and I worked on Pantheon back then, Quorum. I worked on Orion. I worked on all sorts of products related to enterprise Ethereum. I currently hold the title of a chair of the testing and certification working group for the Enterprise Ethereum Alliance, where I build certify a number of requirements related to enterprise Ethereum. I'm also an Apache Software Foundation member, and I've been a committer on Hyperledger Besu for 3 years, 2-3 years, where I contributed a number of enhancements to the protocol, such as ETH65 or the Stratum mining framework. Let me read the chat. No questions so far. Great. So today we're going to dig into what Besu is, where it's coming from. At first, we're going to need to zoom out just a little bit. So before I explain to you what Besu is, if you have no familiarity with Ethereum, let me just walk through why it exists and why it's important in this particular context. So Ethereum is the second largest crypto by market cap, Bitcoin being the largest. Ethereum was started in 2014. By Vitalik Buterin and a number of co-founders who went on and created even more value ever since. And it has many different clients. Some of them are well known, such as Go Ethereum. One was Parity, renamed to Open Ethereum, now deprecated. An up-and-coming one is Aragon. And Besu is, of course, one of those Ethereum clients. Those clients have interoperability, meaning they all work together, and that actually participates in the strength of the network, right? They all have in common that instead of a single application, such as Bitcoin, which was specialized in money transfers, or all the history around crypto, the Ethereum blockchain is the first blockchain that adopted a general computing paradigm, allowing people to create their own smart contracts on top of the chain so they could execute their own very custom logic without the folks building the blockchain knowing about it, right? And so that has come to be called the Ethereum virtual machine, aka EVM. Okay, So the other component of the discussion today is the enterprise, and I'm using air quotes as I say this, as in existing businesses, right? So in 2008, when Rails starting to get a lot of traction, there was also this notion of the enterprise. The enterprise is different. You're competing with existing tech businesses. Think Oracle, think IBM, think all the big players out there. And those enterprises have very different requirements because now they have to have better auditing requirements. They have to make sure that whenever they deploy, all the data is created and owned and hosted on trusted parties. Everything has to be permissioned. Everything has to be auditable, right? So in terms of requirements, now we have a completely orthogonal set of requirements compared to what a blockchain would be by default, which is by default publicly, everything is open, everything is shared, everybody gets a copy of the data, and everybody is able to participate openly into a public network. Now we have a different set of requirements which actually come against what could be possible with blockchain. The Enterprise Ethereum Alliance, which was built around 2017, started to work toward that vision, and you can see a number of logos back then. This is actually taken from the launch, where people started to come together and say, well, we want to see Ethereum in the enterprise. How do we go about doing that? Because we have a lot of work to do to bring this vision to bear. So those requirements, this activity came to with the first attempt at solving the problem. And the first attempt was called Quorum, which has now been renamed Go Quorum. Quorum is an enterprise client, which was actually a fork of Go Ethereum, right? And it was developed by JP Chase, which is an interesting choice of technology. So this is basically a fintech industry based in New York. And those folks have been working in earnest to add additional consensus algorithm, breaking new ground. The big thing that they did that really changed a little bit the way people think is they added a private enclave mechanism, which would allow people to share private transactions on the ledger. So sometimes you would send public transactions where the whole transaction would be available to all the members of anyone who's participating in the network. And sometimes you would choose to instead share only to some members of the consortium, which you would encode as part of the private transaction. And those folks would get a copy of the content of the transaction directly through the private enclaves, which would then gossip the data point to point, right? So there would be no middleman, no actors in the middle passing along those pieces of data. All the data would be encrypted at all times. It would be safe and secure in the vault. There's a question here from Nidhi. Yes, of course. So GEF only supports public transactions. Absolutely. There is no notion of a private state with GEF. There is no notion of a private enclave running along with GEF. This has been added by Go Quorum. The way Go Quorum does the job is by adding a new component to the Ethereum client, which runs separately in its own process and interacts with Quorum, or this modified GEF, to over a file socket, right? And so they would be securely sending data between those two processes. And initially, this private enclave was built in Haskell and named Constellation. It was eventually retired in support of Tessera, which is a private enclave built in Java with a much better versatile set of tooling in terms of support for relational databases and all the places where you could encrypt and store this data in a safe manner. So this was eventually copied a little bit by Pantheon/Besu to make it possible to also interact and remove the need for Go Quorum. The problem with Go Quorum is kind of double. First, it's a fork of GEF, and there are a lot of forks of GEF out there. Lots of projects would just take GEF for a spin, change it, and then go on their own merry way. Not a problem with that, but then you have to pick up all the fixes and all the upstream fixes from GEF. And having seen it up close, it takes quite a bit of work for you to reconcile your own changes with what GEF is doing, right? If you're not too careful, and folks were definitely being careful at JPMC, then you end up spending quite a bit of time applying patches back. If the other issue was that GEF is licensed under GPL, LGPL, which is kind of a no-no for enterprise, because you want to have a private version, for example, a patch version, a well-supported version, a commercial version of your software that you would eventually be able to support. This is just what the enterprise requires, just to reduce risk. There's another question here. Any idea whether your tech may be able to run on top of Notaros/Radix for massive scalability to come? I have no idea about this. You need to tell me a lot more. Sorry, just being honest here. I don't know what Radix is. So now we're going to talk about Hyperledger Besu. Hyperledger Besu is a contribution by Consensus, and you just heard from Matt, and I used to work there. So, thanks Consensus for this. This was a massive contribution to the Hyperledger ecosystem. Back in 2019, it was named Pantheon, if you were around at the time. I feel ancient mentioning this now. And it's a Java-based mainnet client for Ethereum. So in a nutshell, that's how it was sold, right? So we're doing this in Java. It's well known to enterprise developers. It's removing a lot of the weird uncertainty around how we actually work. And it's going to support all the enterprise requirements that I alluded to earlier. Cool. So it's part of Hyperledger. Hyperledger is now just Hyperledger Besu. So just for your curiosity, if you've never really taken a tour of what Hyperledger is, it's got a number of very interesting distributed ledger projects that I recommend you check out. Some of them been around for a while, such as Fabric, which has the ability to do permissioned and enterprise. It was kind of the grandfather in the space and one of the first Hyperledger projects, if I remember correctly. And then you can see all of them have kind of a different type of use case or different types of thinking around how they contribute to the ecosystem. The Hyperledger Foundation itself is, I believe, a Linux foundation, so it's corporate-based. Some members are helping, and you can also participate individually as a committer. If you need to know more, if you want to know more, hyperledger.org is a good place to start. Okay, so an Ethereum client at a high level is actually not a client, right? Or you could think of it as a client, like a mainframe client, right? But really, it's going to work like a server, a peer-to-peer agent. It runs as a single process. It's supposed to be completely independent, meaning that if you have a good Ethereum client and you've taken the time to sync it and it's got all the data from the network, it can perform all sorts of exchanges. So sending collections, submitting collection, gossiping, getting all the data, sharing it with others, and you can interrogate the chain. So you can actually get all the data you want and really pick up with the latest, right? And this is an important point. It's not just Besu. All the Ethereum clients are going to kind of behave the same here, with the idea way back when from the GEF and other clients that you would just need to run this on your laptop, and it would give you the ability to interface and interact with the blockchain at large scale. And well, because of that, it's a complex software stack. So just looking at the open ports that, without diving too deep inside the Besu code base, you can see that we have different types of connections that come out. One is the DevP2P port, which is going to be over TCP and UDP 30303 by default. You have the ability to expose RPC over HTTP with 8545 or WebSocket with 8546 by default. Besu also supports natively Stratum over port 8008, and it can connect to an IFStat server to report stats over time directly here. So we're dealing with complexity off the bat, right? This is no longer a just simple PHP MySQL application. We're talking about something that is going to be hyper-threaded. It's going to have components all over the place. Well, to add to our misery, Besu is also a database, because now we're storing all those blocks. And when we say we store blocks, we will store them in RocksDB file storage on the file system next to our Besu clients, so we can rehydrate and reread that data quickly when we start again Besu. And as you can see, when you look at the structure of a block, this is actually coming from Lucas Seldenha. I tip my hat to him for his hard work back in 2018 when he was trying to explain the yellow paper. I find these illustrations, it's the second time we use it, very useful. We see that when we store a particular block, we're going to store a block Yes, especially its header. We're going to store the transactions that were made part of this block and are organized in the try tree as part of a block itself. So the transactions are here. And we're going to store also the receipts of the execution of all those transactions as we go. Those transactions will impact the world state. The world state itself is made of accounts which contain your nonce, your balance, your code, if you happen to be a contract, and maybe your storage. Your storage itself needs to be actually stored. So all those things are stored into separate files, are indexed as much as possible, and are trimmed over time, if possible, to avoid that you blow away your disk into storing all the intermediate states of all the blocks since Genesis. Any questions about that? Okay, I'll keep strumming around. Besu is also a transaction pool. So when you receive transactions, they float around in a nice little pool. And at first, the only thing we want to make sure is that they're valid. But very quickly, we're going to want to sort them up and order them into a possible block. To do that, we were going to apply an algorithm that is going to sort transactions according to the value that they represent, right? How much fees are going to be brought in by actually minting this block, right? As they're being ordered, we can also see actors, say malevolent, who might want to order them in a specific way, or insert their own transaction before yours, so they can play with what we call MEV, maximum. Oh my God, the maximum. Oh, I have a blank. Please Google MEV for me. That's what happens when I do presentation at 8 a.m. So this type of behavior is actually part of an Ethereum client. If you can't create blocks, then really you're not participating actively in the network, right? There are two types of transactions that can happen. Some of them can be local. I mean, they come through ages and Rpc calls. Some of them are gossiped to you. They're coming from a remote location. So they are actually going to be participating with you in creating the consensus, but that also means that other miners out there are trying to also mint a block that may have those transactions. So if they do, then your block is no longer valid, meaning that every 3 to 4 seconds, you have to recreate and rechange the block that you're trying to mine for a new one to try to keep up with the tide. And MV stands for miner extractable value, right? Sorry about that. Okay. So a few more things that it does, right? So Besu is a network for Ethereum, meaning that it has to know its own truth before it starts connecting to others. And that means it requires configuration. So it's going to have its own Genesis block, which is going to be stored into a JSON file. We're going to take a look at that. It's going to have its own consensus engine, which is usually defined in the Genesis block itself. And it's going to also hold on to boot nodes. So boot nodes are specific nodes that tell you, if you connect to me, I'll give you peers that talk the same language or are part of the same network as you. Without a boot node, you don't know who to connect to. Therefore, you cannot find other peers and you cannot participate in a peer-to-peer network. And that gets magnified through the discovery system that is built into Besu. Besu has the ability to find other nodes using UDP-based messages by default. So first you connect to boot nodes, you ask for what nodes they may know based on your own identity. It will give you a selection of nodes that you will then be able to connect as well to, and then so on and so forth until you reach a certain limit. Those peers get stored into specific buckets. So we use a Kademlia hash table that allows us to kind of sort around the peers that we connect to in separate structures, so we don't get peers that all look the same. This is important because if you don't pay attention to that fact, you can actually get an eclipse attack. You can only connect to a few peers that may feed you bad data, bad blocks, right? So there's a new discovery mechanism now. It's using DNS, using a DNS server that will actually, what it does, it scrapes an existing boot node, gets all the peers it knows about, and stores them in TXT record in a cryptographically verified structure on the internet. So the root record is going to tell you, hey, go talk to those other TXT records, and you keep recursively going down the tree until you discover and read all the information about all the peers which are part of the tree itself. Really easy to download because it works with any DNS server out there. And it's really easy also to check the integrity, knowing the root hash of that particular tree. If you don't like that, and there's good reason not to like that, especially in some settings when you're working in the enterprise, you may use static peering. And then in that case, you set which peers you want to listen to, you want to connect to in your configuration, and Besu will dutifully try them until the end of times. So here, what's interesting is to look at exactly what that looks like. Here is an inode at the bottom, and you can see it's a URI with the scheme of inode. Then it's got this identity user string here, which is a long hexadecimal string. What this is actually is a non-encoded SCCP 256K1 public key that is being represented in hexadecimal format, followed by the host, the port for connection, to connect to the TCP port, and then the discovery port, which on purpose here has been made different to kind of give you an idea what that looks like. The public key is supremely important, and let me explain why by going to the next slide. When you connect to another peer, you're going to use devp2p, which is going to allow you to connect to that other peer by encrypting the message using their public key. The first thing you do when you connect to another peer is you send a hello message which says, hey, I speak those following subprotocols, and I have this much of an identity as well. Then the other peer will be able to tell you whether it supports the languages you speak, and it will allow you to negotiate subprotocols such as if, but in the past, not so distant path, there are other subprotocols such as Whisper. If you use IBFT consensus, it will also use specific messages to reach you to that type of consensus. So you will have different subprotocols for all of those. I don't mention it, but there's also the Light Ethereum service server, LES, which is also something that is supported out there, but is not supported by Besu, for example. So when that negotiation happens, the if subprotocol is then picked. If it's picked and we have compatible versions, because there are different versions here and different offsets in terms of messages, the status message is exchanged and we check that we're actually on the same chain. If we find out that we are on the same chain, that we have all the information in place, that we're good to go, then we can actually start working together. Okay, the question here, what are the benefits of Besu when compared to Quorum? These are interoperable, so they work together. There's the main reason you might want to move to Besu is better tooling, better deployment options, or maybe the fact that it's Apache license gives you a bit of peace of mind in terms of what is possible. And yes, there is a large community around Besu itself. The Hyperledger Besu lifecycle. So you started your client, now what, right? And given everything I've kind of teased to you so far, I think you'd be already able to create a diagram like this. First, you start with your initial state. You come up on the network, you connect to others. You want to get new blocks. What did I miss? You reach the head of the canonical chain. By knowing this, you got from everyone else that they are at the same block as you are, as far as you can tell. If you've not been eclipsed, if you have not been attacked by bad actors, which are feeding you bad data, well, you can kind of pessimistically trust the network to say, okay, I've reached the latest block of the chain that is currently known. At that time, you may start minting new blocks because you feel confident enough that your block might be accepted as the next block of the blockchain. And either you mint or you participate in gossiping new blocks, because new blocks will come through your network by connecting to other peers. And as you do that, then you start having the need to sync again and then connecting to other peers and getting new blocks. So it's never like you start and you can serve requests. It's more of a adaptive cycle where you have to work with a complex reality of working with other peers that may themselves be out of sync and minting your own blocks in the middle of a very chaotic environment. That's the default. That's what happens, especially on proof of work networks. Okay. It's also part of a consensus. So when this is an actual dashboard that we use at Splunk that we kind of built as a proof of concept, where we wanted to show a consortium and its health between different actors all working together to try to understand, whether they're all okay or not. So reporting the health at a larger level. When you work on a consensus, by default, if you use proof of work, which is the default right now for mainnet, any one of the members of this organization may provide new blocks by minting them, by actually spending the time to solve the cryptographic issue of eFash to build a new block. But most of the time, when you're in a permissioned consensus like this one, you would want to use either Click or IBFT. Click, is used by some testnets for Ethereum, and what it says is that a number of those nodes here have been designated as signers and can create blocks, and you're going to have to believe it when you see them. As part of the Genesis block, we actually encode the identity of the node that is able to create blocks, and we go with that particular set of nodes. That can be changed later, but it requires a consensus change using a click specific method. IBFT is also possible. In that case, you select a number of proposers around the network. This is those 4 here are special and can propose blocks, and then they can vote on each other, which reduces the possibility that one of the proposers has gone rogue, and allows for better security consideration. The downside of that, of course, is now you have the need to keep more nodes around to propose blocks. And finally, in proof of stakes, which is going to come after the merge, it's no longer up to the execution layer to propose blocks, but on the consensus layer, we'll see that block construction is made outside of the realm of those blocks proposing, those nodes proposing blocks themselves. So this is all part of the consensus. You can't just have Besu on its own. It gets very boring. And as part of that, you need to pick the right consensus algorithm that works for you. Oh, finally, there's an Rpc server. So there are 4 different ways you can interact with that Rpc server. Here's a very simple method where you always post a JSON blob to the server. You say it's JSON RPC 2.0. You give it an ID so it knows what to reply with, so you can correlate between requests and responses. And then you pass in a method, or you can pass it as many parameters as you want. If you do this over HTTP, it's kind of interesting. You can actually batch it by having multiple of those blobs together in one request separated by new lines. And that's going to be used by wallets such as MetaMask. If you want, you can also use WebSocket, which is going to adopt the same type of thing, but it's a live connection, so you can actually get back using subscription data up to date on, let's say, a new event, a new transaction was pushed into the client. So now you can get that real time. It's more expensive, but people really like that responsiveness. The inter-process communications or file socket approach is kind of the same as HTTP, but now instead of sharing it over HTTP on an open port on your machine, you're just pointing to a place in your file system where you're going to create a socket where folks can interact with you. And it's really useful when you, for example, would like to have admin capabilities against your client and set things like removing blocks, reordering things, changing your consensus algorithm. And that is usually done using GF attach, which is the kind of a client that connects to your client. It's a more secure option, and it was added to Besu back in April thanks to Diega. Finally, you have the ability to use GraphQL. GraphQL allows you to do deep queries inside the Besu state. So you can say things like, hey, I'd like to see what's stored in that particular contract under that slot number 3. So you could dump, for example, the content of all the tokens, the balance of them, who is assigned to. This is useful when you're trying to really understand what's on chain. It's more specialized. It's more of a custom use case for what you're trying to do. Okay, so in recap, No, we have an Ethereum client and it's doing 4 things. It's a database, it's a peer-to-peer agent, it's a queue system, and it's an API. So this thing is massive. It's got a bunch of kinks all over the place. And we're going to dive into that right away. Any questions before I continue? I'm going to respond to the question that's on Discord by saying that, hey, we forgot one more thing, the EVM. Ethereum is special because of the EVM, but where does that play out? It actually plays out everywhere, which explains why you're seeing all those 4 things coming together and playing with each other. It's used to validate blocks. It's used to update the world state, because when you execute the transaction, that's when you know what account should be changed, its balance should be changed, its storage should be changed. All those things come out from the execution of an EVM. And of course, it's used when you want to create your own blocks by executing transactions, so that you can actually understand whether the transaction is valid, whether you can see whether it's failing or not, etc., etc. So the question on Discord is, does Besu support other Ethereum-compatible EVMs? Besu has its own EVM built in Java. We're about to go and dive into this as part of this workshop. Go hang tight, you're in for a ride. And you'll see that it's not possible to swap it too easily for another EVM, because all the EVMs have very specific constructs. If you're interested in EVM as a library, there is the concept of a EVMC, which is a binding based in C, built by the Ethereum Foundation folks, especially Pavel and Alex, who are working on trying to build a more modular EVM layer where it could be dropped into an Ethereum client. You have a question here. Hi, what is the use of API in blockchain Besu? And does cloud involve before sending data to DLT? Well, yes, you actually call this API quite often whenever you ask for the balance of an account, the latest block number, the miner of that particular block. I want to see the receipt of that transaction. I want to deploy a contract. All those things come through talking to an API, the JSON Rpc API, right? And for example, at Splunk, the way we've been using this API is we actually call every block. We call every transaction in that block. We call all the receipts of all those transactions on all those blocks, and we capture all this information into analytical tools, which allows then for us to create dashboards and meaningful visualization of what's happening on chain as we go. So does cloud involve itself? That's a loaded question, because, for example, third-party providers such as Infura, Alchemy, Anchor, I forget a lot of them, are cloud-based and will have a free tier, which you can use to connect to Ethereum nodes, which are going to be running on the back, right? And they work on they work on providing all this information to you, and they cache it heavily because it's really expensive. Because you end up calling this endpoint, for example, to see the latest block number millions of times. If you want to know more about that, there's a number of Infura presentations on the web where they talk about how they had to scale and cache to make it possible for people to connect effortlessly to Infura. Yes, thanks for the love for the logo. The logo's not from me. It's actually from Boris Mann, who built a conference called Run EVM back in 2018 that took place in Berlin. And I think it was a very interesting crystallization of the time, at the time where people were trying to understand, are we going to standardize on the EVM, or are we going to go and build our own? And the answer has been crystal clear so far, that the EVM is still king. It's still being used as a standard layer for execution. Okay. Now, if you want to ask me more questions, it's a good time. I'm just going to catch my breath here. No questions? Great. Let's keep going. So far, I've left you into nice days listening to my dreamy voice about how Besu is coming together. Now, let's get real. We need to configure this thing so it can rewrite. Oh, wait, I have a question. Is there a path upgrade from current EVM to latest EVM? Oh boy. it's not just the EVM. So the way Ethereum is going to change over time is through what is called hard forks, where the whole set of not just the EVM, but how the blockchain works is going to change, right? So we're going to say, okay, we have a new opcode, or we have an existing opcode that's going to change its gas prices to reflect the reality of how much it costs to execute it, for example. And those changes are really widespread. In the next session, I'm showing how these are put together inside Besu, and you can see that nothing is safe, right? From transaction signing to how we reward for blocks, everything there is changeable. So the path upgrade is in your Genesis file. You tell, hey, on that block number, change completely the way Besu works to adopt this new behavior from that EVM to that EVM. Can you explain about static peering? It would be my pleasure to explain about static peering. How about I go back to that slide? So I explained a little bit here that there are different ways by which you find other peers on the network. And sometimes you don't know. You work in a public network, you cannot by yourself find other peers. You have a first step of discovery when you connect to what is called a boot node server, which is going to hold as many node information as possible, get you hooked up to the phone system, right? And then you can call everybody else and start creating your own set of peers. But sometimes that's not what you want to be doing, because you know very well that you're in a permission environment and you don't want to connect to some anonymous peer on the internet and start sending them blocks, especially if you work with the enterprise. So instead, what you would do is you would configure Besu to connect to a select few peers by giving their complete information instead of having to go through discovery. So that would be static peering. Any practical explanation Besu with Rinkeby? Rinkeby is the testnet. Rinkeby is a testnet that is being developed right now. It's been running for years. Besu can run on Rinkeby. Rinkeby has a Genesis file that tells you exactly what type of consensus is being used. Actually, how about I go and do this for you? I'm gonna stop sharing for a sec, and then I'm gonna share my whole desktop. 1 minute, and then we can go here, and we can go Command Shift R. Rinkeby, you said, huh? Rinkeby.json. Here is your Rinkeby file. Here is everything you need to know about it. This chain ID is 4. Started this Homestead block at 1, which is interesting. It's currently up to the London hard fork, up to this, and that particular block. It's currently using click with a block every 15 seconds and an epoch length for 30,000. It's using those boot nodes. And here's information about the first block: nonce, timestamp, extra data, gas on it. The extra data itself here is meaningful because it's containing click-based consensus information, which is going to come useful to know which nodes are allowed to sign transactions. And then at the bottom, you have all the allocation of who got money for how much, right? And this is built into the Genesis block, so you can have people who have money initially when the chain starts. Otherwise, nobody has any money, and the only way to make money might be to mine to get rewards. So that's how Rinkeby works. And to answer your question, there's a question in the chat as well about how you would go about changing the EVM version. You go in here and you say, hey, we're going to update our Genesis block. We're going to add one more hard fork. And you add the hard fork and the block number at which it needs to take place. And that's when you upgrade your EVM. All right. So I'm really glad I got those great questions. I'm really thankful for you taking the time. Thank you for asking me those questions. Keep them coming. Got one more. I gotta thank you. All right. So let's get real. And this question is actually great because they're tying me up a little bit for the configuration discussion. So the Hyperledger Besu configuration, frankly, there's nothing you could do that would not look like a screenshot of our excellent documentation. So Hyperledger Besu has some of the best documentation team on the internet, I guess it is. And if you go and look at our Besu website, it's extremely versatile. So it's really going to give you everything you need to know about the documentation itself. All the options here are stored. The only thing I can do for you today, which is going to help you a little bit and bootstrap yourself as you try to run Besu, is go over which of those options are important. The thing that you need to pay attention to as well is that when you look at this configuration, it's got a little bit of 3 different ways for you to specify options. Let me see if I can go back here. So there are 3 ways. You can do arguments, command line arguments, environment variables, or config file. And it's in that order of priority. So if you're asking yourself, in the config file that I inherited from this particular setup, it's saying this, but it's being overridden. It might be because you have an environment variable that takes over, or you may want to use the command line argument to override that as well. So it's in that order. There's a little bit of a rule here, which is maybe you'll see me use command line arguments throughout the discussion right now, but it can be very easily translated to environment variables. What you do is that you would remove those dash at the first, any dash in there is replaced by underscore, and there's a Besu underscore prefix to every one of those options. So when I say rpc-http-enabled, you environment variable would be Besu caps underscore rpc in caps underscore http in caps underscore enabled, right? Same thing. It's just that for environment variables, dashes won't work, so we're using underscores instead. And then the configuration file itself is written in toml, which is a well-known format by now. Okay, so let's go over what's important. What should we care about? First, options. The network option is the most important one. We just saw Enclave, and in this example, I'm using Dev and Robston. So you can actually set a network, and right away, if it's a well-known network, Besu is going to be able to take that configuration from Genesis file, the boot nodes, the consensus engine. It will know exactly what to do. You don't need to tell it more than that, right? The next option, which is really important, is the data, where it's going to live. You don't get to choose where each of those databases are going to live. You just give it a folder, and that folder is going to be self-sufficient. It will migrate its own data if need be. So you can do a -- data path command line argument to set where it should live. By default, if you don't say anything, then it tends to not live in the working directory, but more into the parent directory in which Besu is run. So usually when you unzip Besu, it's bin Besu. So it's going to live next to the bin folder, which might not be what you want to be doing. It's good enough for development and testing, though, if you're just playing around. For peer-to-peer, that's important because you want to expose peer-to-peer to the rest of the internet. By default, it's going to go and listen to localhost, which is not enabling you to get connection from the internet, which might not be what you want then, right? And by default, the port is 30303. That's been the port for FIM for longest time. And discovery is important. We just talked about that quite a bit at length, right? If you want it enabled, you can say it's true, and then you can say -- boot nodes and use a comma separated set of boot nodes here to connect to them. So these are the first options. If you don't have those, that's becoming really difficult for you to run Besu. But usually you can grab onto this. Here's one that trips everyone, me included. When you start Besu and you forget to put that in, you want to enable just an RPC, it's not enabled by default. Guess what? That happens to me every single time I run Besu. I always forget this thing. So open it up with --rpc-http- enable. If you want WebSockets, then it's WebSocket WS instead of HTTP, right? And then there's another gotcha. By default, the RPC HTTP is going to only support and offer a subset of what is possible for the Ethereum client, because some of it can actually change and alter the chain itself, right? So if you were to expose the admin set of methods of JSON RPC, you may have bad surprises down the road, where an attacker taking over your JSON RPC port might be sending messages to say, hey, forget every block ever mined or ever collected by this client. So by default, the default is if net web3. Web3 is just a little bit of metadata about your client, such as client version. Net gives people the ability to ask for how many peers you have, for example. And if is all the things that you would want to be able to query, such as balance of an account, setting collections, calling a smart contract, things like that. If you need a spec around JSON RPC, there's a set of methods here. Let's click on that real quick. And you'll see that all this information here, so this is an Ethereum Foundation effort around execution APIs. I believe this is still in progress. Right now, you can do things like if get blocked by hash, by number. You can see the chain. You can chain your own. So, for example, Robston is 4. The Coinbase is a miner who gets money, and all those things that you would want to be able to get to. So here's just a ton of documentation on that. That'll be part of the slides. No questions. Okay. Hidden flags. You will not know this if you don't work on Besu, but hey, we've hidden a bunch of things in there and allows us to do all sorts of dirty tricks to you. Haha. So the hidden flags are when we don't know whether we want to really expose this as an actual functionality, or when the developer working on the feature was kind of unsure about the best way to ask for the good default. So we're going to guess at the best defaults are, but we may want to change that during testing, or maybe in some production settings it may not make sense to use the default. A good example here, these are options for the Ethereum Wire protocol. By default, when we ask for bodies, we ask for 128 bodies at times. That might be too much in some settings because you're going over the limit of what this type of queries would be. So maybe you want more, maybe you want a lot less, right? So by default, we don't expose a number of options. And you'll see in our developer workshop that we actually build one of those unstable options. The only rule is they start with --x. So now we get to the good stuff. Ways to run Besu. Go ahead and go to GitHub. You can download Besu right there from there, and you can check the SHA-256 of the download so you're not being abused. You can also install it with Homebrew if you happen to be running on Mac. I believe there might be a Windows version of this, which is Chocolatey. I don't know if it's still maintained. And finally, that's why I didn't put it. And finally, a very popular option has been to use it with Docker. So just Docker pull Hyperledger/Besu. From the source, once you download Besu, its own source code, you can do a Gradle W assemble. In terms of OS support, so Besu has a number of native components, especially around crypto, to make it faster. Because otherwise, if you just use Java for everything related to just adding numbers together or playing XOR, stuff like that, you may actually not be of a compelling performance. So by default, there's actually a Besu-native GitHub repository, which hosts a number of Rust-based or C-based libraries that are compiled natively and then embedded into Besu itself. They support x86. I believe we're close to ARM support, especially M1, which I would welcome. I got a new machine, it's M1 based. So that is going to eventually be in the realm of possibilities soon enough, but x86 has been supported forever. And that means it works, I believe, on Windows, and I believe it also works on Linux. There's a fallback if native dependencies don't work, which will use pure Java instead of native crypto, but it's not as fast. Okay, the advanced options. So far, I give you the easy ones. Let's rip the Band-Aid right away. Sometimes you just want to go and really own your destiny. So you want to set your own Genesis file. You've created your own consortium. --Genesis file is allowing you to point to a JSON file on your file system that says, hey, this is the truth. This is how I'm going to run my network. When we talk about RPC and security and enterprise requirements, some of this is actually normal by Ethereum standards. So you want to, say which host you're going to bind to. By default, we bind to localhost. Might not be where you want it to be bound. Maybe you want to expose it to the internet, which comes with risks. The core's origins, really important. It can trip you up if you're trying to connect to it through a web browser, for example, or if you're trying to get MetaMask to play with you. And then there are more interesting, hardened configuration possibilities where you use a JWT token to kind of authenticate yourself against Besu, whether you use TLS client of connection, or whether you want to use a password type using basic auth, authentication we connect to Rpc. So these are specific to Besu, actually. I don't believe that other clients have this type of functionality built in as much. Another one that's disregarded, but it comes really helpful when you're in pod, is enabling your metrics. You can enable metrics using Prometheus or OpenTelemetry. That's the protocol bit here. So you can say equals Prometheus or equals OpenTelemetry. And by default, I believe the port, I don't remember the default port, but you want to also manipulate the port in the host to see either where you're exposing those metrics, so they can be scraped. You can also decide to push those metrics using Prometheus. If you are attempting to do proof of work mining with Besu, you're in a treat. You can enable mining, so that would actually enable CPU-based mining, but you can also enable Stratum-based mining, which then opens the port and allows miners to connect to you over the Stratum protocol. And I believe Besu supports if proxy and Stratum 1. And so those two different types of protocols are supported. You can connect to them using your miner, just pointing at the 8008 port by default, and then you will be able to mine blocks using Besu. So let's go into some exercises. We're right on top of the hour, which is great. We're going to start running Besu on our own low network. So if you haven't done so, I invite you to go and download Besu or install it or build it from the source and run it with those two options, --network equals dev and RPC HTTP enabled. So what does that do when we say dev? Let's actually take a look. What that does is it points us to a dev.json Genesis file, which is going to be stored alongside Besu as part of its class path. So when Besu runs, it finds the dev Genesis file, and then is able to configure itself. And there's a number of things to really pay attention to as we go here. First is the chain ID. 1337. It's the default chain ID for that particular network, and it's useful because it happens to also be the local host 8545 chain ID in MetaMask. So we'll be able to very easily add ourselves to MetaMask in here. Got a question. Oh, I've been trying Gradle W build inside Besu WSL2 repository. It's been built for 30 minutes so far and states only 1% done. Is it expected behavior? It is not, but I have no idea what WSL2 is. I have no idea what WSL2 is. Windows subsystem for Linux. Oh, if you're in Linux, just build it in Linux. It's not expected. Okay, let's go back. So what if I want to run my private network? What should the value of network flag? Then you can't use a network flag. Network flag only works for well-known networks. So here are all the well-known networks. We got Aster, Calaveras, Classic, Dev, ECIP 1049_dev, Gurley, Kiln, Coty, Mainnet, Mordor, Rinkeby, Ropsten, Cipolia. Awesome names, probably meaningless to most of you, but that's the network that you can use, right? And you definitely don't want to use that if you're going to build your own, because these are all public and shared. So yeah, Miles, please let us know if you're able to build it outside of the Windows system. I'm interested to see what's possible here. So here in the particular dev network that we're going to run, we are going to say that our first block is a Petersburg block hard fork at block 0. We're also setting some configuration. So the contract size limit is quite big, actually. I think it looks like it's 2 megabytes. Looks like it. And then we're going to run with a proof of work algorithm named ifhash, but we're doing a little bit of a stint on it. We're saying, hey, it's got a fixed difficulty of 100. Our first block has a nonce of 0x42, which is in hexadecimal, so it's not actually 42. Timestamp of 0, so 1st of Jan 1970 at midnight, sure. Extra data, the extra data is just 32 bytes up to us. And it's got some gas limits, some difficulty. All those things are kind of arbitrary because the Genesis block is kind of made up as it is. And then it's allocating a number of addresses and accounts. And you can see that they have additional information that you may not see in other Genesis files. The first thing is, this contains the private key, the private key of the account. And the private key in this comment are ignored, and in real chain, the private key should not be stored, right? You definitely do not want to be passing around the identity of actors of your chain alongside your Genesis block configuration. But that's helpful for us because we're going to be able to import these identities inside MetaMask. Another question. So I'll say one thing. If you use build, you're actually going to build, test everything, test all the things from unit test, integration test, acceptance test. You might be better served by just doing an assemble task, which then bypasses testing. Otherwise, you're going to spend quite a bit of time waiting for the test to run, which is not a bad thing, if you don't want to trust that code blindly for sure, but also takes a while. Okay, so let's go back to our exercise. Let's see. I have right here a little bit of a terminal. I'm pretty sure it's unreadable, so I'm going to change my preferences, and I'm going to change my background, and I'm going to make it as clear as possible. Maybe it's too much. Here we go, a little gray. How about that? Can you repeat about including the private key or not? Do not put your private keys anywhere. Keep them safe. Bring them. Do not share them. Do not share them ever. Right. The only reason they're in the dev.json file is because the dev.network is used for testing. Do not put real funds associated with those accounts. Do not transact on those accounts, even in mainnet, because this private key being known, people will scalp the money stored on those particular accounts, right? And so this is great for testing. It's great for development. If it leaves your computer, you lost the war. We're going to try and run Besu now. So I happen to have. Oh, that's not good. Okay. Okay, so I have Besu on my laptop. I have it built. I have it unzipped here for the sake of building from scratch. We're going to unzip it again. Okay, so now I can go into it and let's follow the exercise. So I do network equals dev and RPC HTTP enabled. Oh no. Okay. That's what happens when we do demos. Huh? We're going to build again. So as we build, we are reconfiguring, we're compiling all the code that needs to be compiled. Takes a little while. It's a classic issue where some of my code is in the next workshop. And because of that, we're having a little bit of an issue, and I don't want to spoil the surprise by passing an argument that shouldn't. It's already at 9%. Miles, I'm beating you already. That's great. I'm really close now. The percentages themselves are not actually worth paying attention too much to, because they are not based on the actual wait time. They're based on the amount of work, number of tasks that Gradle has to perform. Gradle itself is a little wrapper that is building using Groovy and picking which options to pick from. As you can see, we're already at 57. Now we're building the tar GZ distribution. Now we're building the zip distribution, which is exactly same contents. And we're just compiling the acceptance test. And we're building an additional tooling called the EVM tool as well. Okay, so build distributions. You can see I still have this folder. I'm just going to remove that. I'm going to unzip again. And I'm going to go in the folder. And then, if I remember correctly, we had bin Besu, network dev, Rpc HTTP enabled. All right, no existing database. We're just starting. We have peer discovery agent on here, and you can see that our system is now up. It's even created its own inode as part of setting itself up. So it's got a public key here that is advertising to the network, and it's saying, "Hey, I'm proudly, exposing myself on 127.001.30303." Which means that this client is pretty much unreachable at this time, which is great for what we're trying to achieve here. We're not trying to connect to others, but either way, it's still going to wait forever to see if other people are going to join. So the first thing I'm going to do is do a curl over localhost 8545 with this application JSON, and we're going to try to get the balance of this account. Why is this account? This account is listed here as a second account here. So what is the purpose of Gradle build? Is it the obvious to test if the build is ready to build? Do you run Gradle build when you want to not only just build it's the default command in Gradle, and it's used to build and test and run everything that could be possibly under the hood with Gradle, right? So it's not so much a Besu construct. It's actually something that is being inherited from Gradle, which stole the idea from Maven, where as a Java tool, a build is a complete build. But if you're just trying to package, get the zip file that contains the Besu stuff, then you would want to just run assemble in Gradle and package in Maven. And that's been like that for a while. This is just a philosophy thing as part of the life cycle of this software. Oops. So let's see if I can copy that. Nope. Okay, I'm exiting full screen so I can copy that text for you. And you can see, so we're using backticks here because we are using Linux-based systems or Bash. And then we don't need backticks anymore in this because there's a single quote that is around the JSON content. So, hey, you know what? Let's try. Okay, looks good. All right, so we've got a result here, and that result is this huge X. How do I make sense of this? Let's see. I got a little website here, utils.themachine.io, which I own. And if I put this hexadecimal in decimal, we see we're fluffy rich on this particular network. Good work for everybody. We can just retire now. We have 90,000 ETH at our disposal. So those slides are not quite shared yet. I'm sorry, been working on them till the very end. However, we have a basic workshop with all the instructions, and I believe I did a good job of pasting them here. And you can, let me put them in the chat. Okay, we got 2 minutes. You're gonna play something more advanced. let's go and actually add it in MetaMask, right? So for MetaMask, we now have to play with the security setting because MetaMask is going to connect to us through a Chrome extension. If you look at this Chrome extension, it's extremely specific, which I think is a great idea. And so we're going to say that we're going to allow MetaMask to connect to us over course origin right here, okay? So let's go and kill, like just pressing Control-C, right? You can kill Besu. You can see Besu is stopping, it's stopping its network, it's stopping synchronizer, it's being very nice. And now I can paste this additional set of instructions, which are a little nightmarish to look at. I'll admit this. And Besu is back up. Okay, so if I did a good job, I'm not locked out of my MetaMask, and I can share it with you and show you. Ooh, look at that. So I've done the work, which is not a good way to do it, but I have already a localhost 8545. By default, if you go to mainnet, you'll see that this Besu dev #2 account is completely out of money, which is really unfortunate, but hey, it's okay. Let's go back to localhost 8545. So if you scroll down, you can see all the well-known networks here, and at the bottom, you can see localhost 8545. Click on it. You can see that your account may not have any money yet. So how do I go and add this account? Let's import a new account by entering its private key. Private key said yes in the dev.json file that I shared earlier. Sorry, Zoom is getting in my way. There was this notion of a private key here, and I have not imported this account yet, so I can copy and paste this private key, right? A question in the chat? Okay, no question in the chat. So now we're gonna go into here again. I'm going to click on this. I'm going to click on import account, private key, paste, import. Account number 7, I have this many accounts, has 90,000 ETH as well. And how did you do that? You did that by connecting to your Besu locally, getting all the information, and now you can do all sorts of interesting things, such as sending money between accounts, playing with the data itself. You got 9 accounts. That's just showing off. Yeah. So, of course, you can have more than 9. So thanks for showing me. Priscilla, I'm not sure you should disclose they have that many accounts. I think you just target, you place the target on your back just now. So this is how you can play a little bit locally with Besu. So already now you can do development. You can do like deploying your own contracts and play with Besu locally and do all sorts of things. Is that real? The ETH amount. Its amount is real on this dev network. It's not good at all on anything else, right? Nidhi, we're going to get right away to this network idea with 4 Docker containers. We're going to talk about that. That's our next view. First, we're going to agree on what we're going to do as a consortium to work together. I gotta say, so far, timing is great. We're right on time. So, if you have questions and you want to derail a little bit this thing, let me know. For our Genesis file specification, we're going to go into a tutorial, which is not mine. And I just want to spend a few minutes for you to understand how we go about creating our own IBFT network. And the great thing here is that, you have this ability to then read the docs as well and see exactly what's what. So the first thing that needs to be done here is to build a Genesis file that is going to be specific to you in your enterprise with your 4 nodes, for example, like you're trying to achieve here, right? So when you create a configuration file, you're going to give it information such as its chain ID, its block, IBFT information, allocation of funds, and here in this particular setting, it's also adding some custom things such as blockchains, number of nodes, generates those nodes and their count, right? You want the tutorial link here? Okay, no worries. You can follow from here. So all those actors, right, are being placed in here in this particular configuration. Now, what I want to pay attention for you to is that we're doing something here a little unnatural, which we're adding additional information. This information is not to be located in the final Genesis configuration file. It's only going to be used because we post-processing this JSON file into a Genesis file. So using OpenJDK 16, so you could try to work. Wait, you're using Ubuntu. Interesting. Okay, Miles, for now, you can try to work with a download of Besu if you're trying to apply here, or a Docker pool. I'm not sure how to help you. Okay. I read that kubefts should be used over other consensus protocols in an enterprise environment. What is the advantage? Well, so kubeft has been around longer. It's been tried and true. kubeft has the immense advantage of being used by both Go and Besu, so you can actually swap clients and you'll be able to continue making it work. IBFT2 does not by default have private state, if I remember correctly. So these are unrelated. Yeah, these are actually related. So for the purpose of this, they actually look quite similar in terms of configuration, because you have to, in both cases, set up the signers on your node system. So the thing that's being at this point used is that Besu has a subcommand called the generate blockchain config using a config file to network files, and it's a string to generate the Genesis file, but also going to generate the accounts, and it's going to allow you to keep going like this. There are two more questions. Okay, so this then creates all those things. And this is important. I really need you to understand this. The genesis.json is actually existing here, right? All the information is already loaded. The only difference is that it does not have an extra data string. This extra data string is actually generated using this approach, and it contains the keys and information about all the 4 signers that we're going to allow going forward as part of the consensus algorithm of this particular network. Right, so the genesis.json now has an extra data, which is the encoding of those 4 nodes identities using RLP, which is an encoding algorithm used by Ethereum. And the directory of it has the key and the public key of each of the 4 accounts, which will be allowed to sign blocks for each of the operators. So each of those nodes, they'll want to have those identities so that they can operate as part of the network and sign blocks. Now, that's exactly what we're doing. So we're copying the data in each of the... Sorry, go ahead. Okay, each of the data of all of those nodes is going to be copied into different nodes directories under the data folder where the key and key.pub are being loaded. And as you can see, then you run them with genesis.json file. You point to the data folder next to you, and you say, "Hey, make sure I pick up that key file," which is a default path to that key file inside the data path. This is important to get. It's a little bit of Lego assembly, and it's a little painful because sometimes that's when we mess up. Speaking of experience, frankly, but if you get this way of building the Genesis, then everything else goes smooth. And it is the same thing for kubeft. So I bear good news. I don't want you to do this right now because I think it's quite involved and it's not a lot of fun, but I have a shortcut for you to go through the finished result. And if you're game, we can go to that right away, unless you have questions. Okay, this tutorial is right here for you if you need to. Again, I'm coasting on our excellent docs. There's no question about that. Our docs team has been excellent at delivering great docs for Besu and tutorials. So those tutorials, instead of trying to recreate them, please follow them. They're really good. And if you have any questions, those docs are actually also open source. You can open issues against the Besu docs repository, and you can also contribute to that repository and help it become more comprehensive over time. So, Consensus has been a great actor as part of this ecosystem. And there's a way for you to, instead of having to do the gruesome work of building your own network, get a kind of a quick start approach to it. So you can start with something sane, and then you can customize it to your needs. So it's got a number of defaults that it's going to try and pick up for you. I'm going to paste this in the chat. If you're familiar at all with this command, you should pick up right away on npx. npx allows you to run the Chrome dev quick start node module directly without having to install it or do anything with it. And the Chrome dev quick start npm module itself, let's take a look at it on npm.js, so you're not spooked by running some code on your laptop. Is right here. It's well maintained. It's published 4 days ago now. It's got some interesting things here. You can go to the GitHub. You can see it's not, you're not about to run something that is a bad actor. It's only going to generate files for you. It does not actually run anything after that. So it's also very lightweight in terms of, it's not lingering around on your computer. So let's kill Besu. It's been running forever. Now we're gonna go back to my little Besu workshop. In the Besu workshop, I have some instructions on how you run npx, but frankly, let's just do it. So I did say npx from dev quick start, and you can see it's downloading the Chrome dev quick start from npm.js, and whoa, got a prompt. All right. So we can create our own network. It's great. It's going to use both Docker and Docker Compose. And we get to pick which client we want to run. It can be Hyperledger Besu, it can be Go Chrome. Great. I want Besu. We'd like to try out if I orchestrate. I'm going to opt out that for now. I'd love to Chrome Key Manager. No. I'd love to have support for private connections. Yes. Is there any logging that you want? So we can support Splunk or Elasticsearch. I happen to work for Splunk, but today I'm going to just want you to really spend the time on Besu itself. So none. Do you want to enable support for monitoring your network with Block Scout? No. Where should we create this? By default, it's going to create it under the Chrome test network folder. Sounds good to me. Installation complete. Now you can run it with run.sh. Wow, what kind of black magic is that, right? So let's copy it. And it shows right here. And it's got a number of things in here. Let's actually open it with Visual Studio Code. Nope. Yep. Okay, so we're in Visual Studio Code, and we are looking at this new folder that was just brand new created. First thing to look at is the Docker Compose. The Docker Compose itself is using YAML anchors to allow to avoid recreating several times the same content over and over, right? So it's going to create a Besu, it's going to create one tessera, and then it's going to apply that all over the place for all the Besus, for all the tesseras, and so on and so forth, right? So it's got all this configuration in those aspects. So when you start Besu, if you're familiar at all, it says bin bash copy genesis.conf. So we would want to take a look at that. And then we're going to run Besu with the config file. And you can see all our familiar RPC HTTP API here, or RPC WS API here as well. So we're really opening up Besu to be used. The config file itself is under config. So let's go to config Besu. config.toml. And so you can see all the configuration here has been created. We get all the RPC setups. We allow requests from any course origin, which is interesting. We have GraphQL as well enabled. We have metrics enabled. We have some permissions, and we have a boot node. The boot node has been generated for us over that IP. So one of the nodes is going to be special in the sense that it's used to run as a boot node, right? And then finally, we can use static nodes as well. So let's take a look at those static nodes. The static nodes have been generated as part of the run, right? And so we can see all those nodes here all have the same public key, the right public key setup for each of them, and then they all have different IPs. Those IPs are actually being negotiated when we set up the Docker Compose. So let's go down a little bit. Let's say, okay, we have a Besu node here, and you can see we hard-coded the IP as part of Docker Compose. Allows us to make sure we're running to the right node when we say so. It's also got the right key. So the config node validator 1 folder has the right key for opt Besu keys. Well, I only trust my eyes so far. So config node validator 1 node key. There we go. This node key here is actually the private key that identifies our node on the network, and that's the pub key for it. So the quick start has done the hard work of wiring all those crypto elements together so you don't have to, right? And it now helps you go much faster at understanding all those elements together. So all those Besu dev nodes are now being set up, right? They're exposing ports. So it looks like this RPC port, for example, is going to be exposed over 21004, et cetera, et cetera. And then we have additional tooling such as if signer proxy, which will allow us to send data and sign it as we send it to the network. Next, we have the private enclaves. So we have Tessera, which is going to be at a private specific port as well, and is going to connect to one of the nodes as part of that. Any questions about any of that? I'm looking at Discord and I'm seeing some folks being feeling amazing today. It's great to hear. Okay, so this is where I'm going to leave you in terms of exercises. I'm happy to answer any more questions at this time, anything at all you may want to ask. But this is a quick tour of how to run your own private network by having it being generated, so you don't have to do the hard work of actually wiring all those things together. I would say it's a quick start. It's not the end. For example, if you look under the Enterprise Ethereum Alliance GitHub, I use this as a start, and then I modified it to actually smash together Besu and Gokoram working together over a QBFT algorithm. Miles, I'm really sorry that you're having issues with building on this particular setup. Yes. So let me drop in Discord as well all the Besu workshop reference material. This is going to be here. Of course, it will all be coming together from the slide deck as well. So we'll post that as well, and we'll all link together from our wiki on hyperledger.org. So we'll have the ability to really help you with that. Now it's a good time to ask me any questions you may have around executing, running Besu, any particular behavior you'd like to see, any enhancements, anything I left out. I left a ton out. There is some additional workshop materials that I know some better versed people on permission networks who want to contribute. In particular, I did not talk about the smart contract based permissioning, which allows only some members of consortium to do certain actions. I believe this should come into a separate workshop because it's on subtopic. It's quite interesting. If you have any questions at all, feel free to ask me now. I like to take a minute to find my voice again, and then at 10 a.m. my time, we'll continue on the journey of actually building and extending Besu and really create new opcode and deploy that and actually play with that. Just checking the messages here. Some questions trickling through. All right, one question I'm getting is which Rpc URL did you use to add a new network to MetaMask for the local DevNet? So let's take a look. I'm still showing my whole screen, hopefully looks like I am. If I go to MetaMask at any point in time, I can pick a different network. By default, the network is going to pick is always going to be Ethereum mainnet. But you can also choose to go to another main network. Let's see Ropsten, right? No ETH on Ropsten. Oh. Maybe Rinkeby? No Rinkeby. Okay. But if we go to the bottom of this, we can add localhost 8545. Oh, you know what happened? I killed Besu. So it's no longer able to connect to it. It's no longer able to actually tell me what the balance of my account is. So it's going to just keep failing here. How about we do this? Believe I was right here in this thing, and then if I just go up, I find Bean Besu Network Dev, Rpc should be enabled. I have the HTTP course origin sets to localhost and this Chrome extension. Have you seen? You've seen this in the config toml file. You can also just put star in there if you just want anyone to be able to connect you. It comes a risk that someone might be able to hijack your RPC port. So let's run Besu again. And now Besu is up and running. Let's go back to here. Something went wrong. Oh, really? Let's see. Connect again. It's just not gonna let me. Here we go. So we're back on, and we have this. If you go to, I believe we can expand this. This is a little bit of a MetaMask trickery. You can have it as its own. Then you can do things like looking at the settings of MetaMask. So you can add networks, for example. If you actually go to the networks, you can see localhost, and you can see it's by default set up to HTTP localhost 8545. The chain ID is 1337, and the currency symbol is ETH. You can also set a block explorer URL if you want to. So if you run your own consortium-based, enterprise development, you can also allow for that to happen and for you to connect to an RPC node. For the Enterprise Ethereum Alliance testnet, that's what we do. We actually have an RPC node, and you can connect to it using MetaMask, and all those instructions are located in the EEA GitHub, which is members only. Oh, more questions. Thanks. It seems that it doesn't accept the chain ID. I guess I'm lacking some configuration. We'll try in a bit. Yes, the chain ID is a thing that MetaMask will really not like if you don't provide it exactly the same. So here it happens to be coinciding. Chain ID is being set to 1337. It must match a chain ID written by the network. This is because of the ETH versus ETC clash. ETC starting to use the same chain ID as ETH. So as part of that, the two networks had to kind of separate each other, and to do so, include the chain ID as part of signing transactions. So someone could not use a transaction that was signed on ETC and replay it on Ethereum itself. If you look inside the dev.json, this is at the very top. The chain ID is set to 1337 there. If it does not match, either your MetaMask is not configured right, or maybe you're not using this dev environment and you're using your own Genesis file instead, which is perfectly fine, but just make sure they coincide and then you'll be good to go. No worries. Any other questions? Here is the plan. I'm going to take questions for another 5 minutes or so. And if you would allow me, I'd love to take just a pit stop for 10 minutes. And at 5 to 10, we'll start again and we'll talk about development. We'll talk about how to build on top of Besu. And we'll get dirty, a little bit of a, you can already, if you have the Besu workshop materials, you can already see a little bit what we're about to do. We're about to get really deep inside building our own EVM opcode and then deploy a contract that uses it and play with it a little bit. And you can see that in the extend. I'm only telling you this, so you come back in 10 minutes, right? You can use that as part of a complete deployment that allows you to play with this new opcode and call the contract and deploy contract. It actually makes sense. All right, going back to my question slide. Feel free to ask questions just by raising your hand, or just get off mute and ask me anything, or go to Discord. Feedback is important to me as well. Did I leave anything out? Is there anything you'd like me to go over again? Feel free to ask.
Hi, Antoine. Actually, a bit of an unrelated question, if I may.
Sure.
When building a Docker image for Besu and, for example, deploying it to AWS, is there any metrics that or measurements that you can tell me about the GraalVM versus a normal JDK? Is there a significant speed up using GraalVM?
Oh, that's a very good question. Thanks for asking. I believe there is a speed up, it's currently done, I believe, in a Docker build. So I don't know how significant it is. I know that the build is much more grueling in a way. I haven't seen any benchmarks on that particular difference. I've used GraalVM in a different setup where I saw 20x type of improvement in terms of at least startup times and things like that. So let me answer as best I can. GraalVM is currently supported by Besu. It has not been put on the foreground as the premium or best way to run Besu yet. And as far as I can tell, it's mostly used as part of the Docker build. And so it allows you to play with it right now. But yeah, I haven't seen a benchmark that says authoritatively, hey, you should use that, it's 20x faster. But I believe it is much faster. If you're interested, let's see if I still have that. Open in our Docker, there's a Docker folder in here with GraalVM. And the Docker file itself is a little involved, but not that much. And you can see that it's just taking Besu and running it on top.
Yeah, thanks for that answer. That's actually how I discovered this, so that's why I'm asking. But yeah, if you don't have any benchmarks, that's okay. Thanks for the answer.
Yeah, no worries. I'm going to eat my words a little bit because what I'm seeing in this particular Docker file is that it's running on top of the GraalVM as a JVM, but not actually as a native artifact. Like you would want eventually is that you would actually build Besu natively down to a binary that would actually be just executed on its own. And I don't think we're there yet in that state. I think there's a couple issues around having native bindings and things like that might get in the way. I think the GraalVM approach makes sense to me. So yeah, if you want to help with that, that sounds like a great enhancement for Besu. The only cautionary tale there is that it's a long build process because you're compiling and assembling together every bit of a binary into one huge binary that can be hundreds of megabytes big.
Yeah.
Vijay is messaging me as well. Vijay's been sending me a message saying, hey, Antoine, I'd love for you to share EA links that you mentioned. So the Enterprise Ethereum Alliance is a members-only organization sharing with you content that is supposed to be for members. Not great, but some of it is public. And I'm not above making some publicity for my hard work. So we're going to go over the KubeEFT testnet. The KubeEFT testnet is this quick start testnet that I customized to mash together Chrome and Besu. And in that testnet, I removed a number of complexity of things I didn't need for the particular use case that we had at hand. In our Docker Compose, you can still see that we're using this, YAML anchors with xbesu.node-dev, and we're also using that for Chrome. And then we actually put them together for all of them to work together as is, right? So validator 1, 2, 3, and 4. 2 of them are Besu-based, 2 of them are Go Chrome-based. They work together using the right keys to come together of a consensus, of a KubeEFT consensus. On top of that, we have an RPC node, which is a separate deployment, which allows us to connect to it and send transactions. By default, you don't want to expose your consensus nodes to RPC traffic because it might get really noisy. And we have an if signer proxy and other utilities such as Cakeshop, Explorer, Remix, Prometheus, Splunk, as I believe, CAdvisor, eFlogger, which is a Splunk-based utility that allows us to get all the data and take it out, the Open Telemetry collector to connect all the information from Besu and others in terms of metrics. And so all those utilities kind of surround the environment of a very simple 4 nodes for consensus, 1 RPC node, which are being hosted as part of this Docker Compose. And this is what it looks like.
Thank you,
This is open source. No worries. I believe it's open source under Apache licensed, so you can get heavily inspired, and you would be more than welcome to steal from it. If you're interested in the Enterprise Ethereum Alliance activities, there's a testing working group, which is a separate repo where we host the actual configuration and some of the permissioning, such as the private keys and all the initial locations, all those things. So members of the Enterprise Ethereum Alliance can come in and say, hey, I'd love to be able to transact on that testnet. And we tell them, of course, here is an account that you can use for all sorts of running and allowing you to play with the data itself. All right, I'm going to take a 5 minutes. No, sorry, there was one more question. Is there a way to prevent the Besu node from deploying a contract in a private network? Is there a specific setup for that? Or maybe we're going to cover that later on. We will not be covering that later on. It's way above my pay grade. I am not good enough at this to tell you exactly how it goes. However, there is a set of functionalities in Besu right now that allows you to curtail who can deploy and who can transact on the network according to smart contract specification or according to a permission node setup. So the permission node setup only allows some of the nodes to participate, and the smart contract specification allows to set up who can actually do deployments or contact on the network itself.
And that's a good reminder that earlier, for the people who may have missed it, Matt Nelson from Consensus was on earlier, and he said that they're putting plans together for future workshops. If there's content like that that's not covered here, but you'd like covered in the future, you can just fill out this short survey. I would drop the link both on Discord and Zoom chat.
All right, this is my chance to grab 5 minutes of rest, and then we'll get back in the saddle, and we'll do 2 more hours where we do a little bit more around development. I'm going to queue up our next presentation, if I can find it. I'm getting in the way.
And Antoine, while you're taking a break, I'm happy to answer any questions people have about Hyperledger in general, the community, or anything.
Perfect.
People are welcome to take your own break, or if you have questions, I can help answer. So I think, as Antoine shared earlier, Hyperledger Besu is just one of the projects at Hyperledger. So if people have questions about Hyperledger in general, feel free to ask, and I'm happy to answer. If not, we can just hold on, and then Antoine will be back in a couple of minutes. So just a little bit of background about myself, just to give context about the questions I can answer. I've been at Hyperledger for almost 5 years now, Senior Director of Community Architecture. Have a long history with open source, so my focus is on the Hyperledger community, making sure that the community itself is healthy and that people who want to get involved can get involved. So any questions you may have about getting involved with Besu or other parts of Hyperledger, I'm happy to give you some suggestions and pointers and share some links. Okay, I see there's a question about fintech. That's great. Let me share some links. So just to give a little bit of context about the Hyperledger community, there's really 2 parts to it, or 2 main parts to it. We have the projects such as Hyperledger Besu, Hyperledger Fabric, for example. You know, those are developers around the world coming together, creating these different tools. But if it stopped there, that wouldn't be enough. We also want to help people use these tools. So I just dropped a link to the special interest groups. So we have a number of special interest groups that are helping build open communities around taking these tools like Besu, they're getting created, and applying them in different places. So for example, we have a financial markets special interest group. We have a healthcare special interest group, telecom, supply chain. So kind of it really runs the gamut from a number of different things. So if you're interested in applying, and I'm just dropping a link, for example, to the financial market special interest group, because there was a question in chat about fintech. those are good places to go to get involved. Again, you're welcome to get involved in the development of these projects themselves, but if you're interested in how these tools are getting applied, I really think the special interest groups are something to take a look at. So those are open as well. All the special interest groups have regular calls that are open. The dial-in information is on the wiki. They have chat channels, they have mailing lists. So if you have questions or you want to share what you're doing, or just get involved, connect with other people that are looking at using blockchain or distributed ledgers in a given industry, the special interest groups are a good place to go. And they also have they have presentations like this too. It is really a great place if you want to see use cases in a given industry. A lot of the SIGs do have regular presentations where people share about what they're doing and talk about what they learned, and you can ask questions. I don't know if that answers the question posted in chat about kind of fintech and blockchain. If not, I'm happy to talk more about that. Here, I'll share another link here. Another good place to go if you're interested in a specific area like fintech, or pick a different industry, telecom, healthcare, etc. There are a number of case studies that have been published on the Hyperledger website. I just dropped a link to that in the Zoom chat, and you can go there and learn a lot more about what people have been done. These are in-depth looks at a business case that has been addressed or solved using distributed ledger technology. So for example, here, this is a perfect one. Here is a case study about what an organization called Public Mint developed with Hyperledger Besu. You can see I don't have the ability to share my screen right now because Antoine is currently sharing his, but if you click on that link, oh wait, okay, let me share my screen then.
Maybe I can give you access, yeah.
Okay, great. Is my screen showing up?
Just
No.
give it a sec.
Yeah, I have actually had a problem with Zoom recently not sharing my screen. So let me stop. Maybe Antoine, if you don't mind just clicking on that link.
Yeah, no worries.
Sorry, I know you were taking a break, so sorry about that, but
No, break's over. It's okay. I've done.
But I think this is relevant because it is a kind of an example of Besu being used in production. So again, I dropped the link to the case study area in the Zoom chat. You are welcome to take a look. This, again, is an example of the different case studies that are there. We worked with a technical writer to really do a deep dive on a specific production use of a Hyperledger project. This, again, one being done with Besu. So if you're really interested in how the technology that Antoine is describing is being used in production, check out these case studies. They do have a lot of information in them. And again, if you want to get involved with people using Besu and other projects in a given industry, the special interest groups are a great place to go to get connected to people. So if Antoine's back, I'll stop. But if people have any additional questions about the community, I'm happy to answer them on chat.
Thank you, David, so much for helping and providing context and a view into the business of how to use Besu. I think this is instrumental. We're not just building bits; we're also operating real money.
Yeah, exactly. If people were developing things and it just sat in a repo somewhere and nobody ever touched it, what's the point, right? We want to build these tools and have people use them too, right? So
exactly. And so we're 3 minutes away from starting our next workshop. I'm going to queue up a number of things here. Let's see. We're going to go talk about extending Besu. Before we get started, I'm going to implore you to follow the prerequisite steps and as much as possible, install Java, Git, Docker, maybe Docker Compose. We will not use Docker, we will not use Docker Compose for this section. It's only for the operation and running Besu, and especially if you want to run the quick start. So you might be able to skip away from Docker and Docker Compose. Let me paste the prerequisites in Discord. Let me paste them in the chat as well. For this session, I will be spending quite a bit of time in an ID, typing away code. It may not be for your liking. If you don't like it, say so. Let us know how you feel, because otherwise I can really geek out for hours into how I pick this particular Java class or what's going on here, right? So if it gets too technical and it's not what you wanted to hear, I'm happy to take it a notch faster or different, or give it a different pace so you can have a better experience. If you want more, we can give you more. Someone is typing away in Discord.
I was actually, but it's going to be easier if I ask it vocally. So the link that David shared was speaks to how the tech is being used now, right?
Mm-hmm.
And then, so is there a long-term vision where Besu is going technologically? Because I know that there has been a lot of work in terms of, for example, the privacy groups and the flexible version of that and stuff like that. So is there a long-term vision for the technological stack?
Yeah, so there are two different visions which kind of complement each other and are a bit at odds in ways. One is the mainnet pool. So there's a huge pressure on the development team of Besu to keep up with the mainnet changes, specifically the merge, specifically all the changes coming through that have been really interesting, but are quite taxing in terms of time from the team, from what I can see. Besu is also not just supporting the merge, but also supporting Ethereum Classic through a set of different committers. They've been supporting all the changes there, making sure it's still compatible with Classic. So this is actually taking quite a toll in terms of effort on the team. The biggest push that the Besu had over the last 2-3 years has been to get itself to compatibility with Go Quorum, with the explicit goal of eventually being a better contender for privacy in enterprise use cases than Go Quorum has been. But Go Quorum had quite a bit of an install base, and the idea would be to eventually replace Go Quorum with Besu in a safe manner. And for that, there's a separate team that's been working on, harmonizing the different clients and making sure that they can get to parity. Now, parity has been reached, I think, a year ago. Now we're entering the phase where Quorum is being offered by Consensus itself as a service as well. So we're starting to see a little bit of a stability happening. We're starting to see a bit more of a market around that's playing out. The thing that needs to happen to kind of keep propelling this offering forward and to see in terms of privacy, what they want to do, is to have more of this type of use cases that David was advertising just now. So I believe it's now in the maturity stage where we don't want to bring a lot of changes to the code base on a whim. And there's been some interesting under the radar feature improvements, such as adding support for new encryption algorithm, which are actually FIPS 1040 compliant. So allowing folks to actually play with the existing fintech industry and being, for example, used by MasterCard currently. From what I'm seeing, is folks from MasterCard actually made some very significant contribution to Besu to make it this much more modular and available for fintech. So that's where I would go, is that it's going to be based on those type of use cases, more community-based on the enterprise side, and it's going to be quite opinionated and very extensive on the mainnet side, because that's where some of the innovation is coming from.
Mm-hmm. Awesome, thank you for that. And then, so you mentioned the team yourself. So out of curiosity, how large, if you can share that, how large is the team contributing to, like, actively contributing to Besu?
Yeah, it's not a secret. Let me see. So
yeah, we have a metrics dashboard that has a lot of that. I don't know if you're pulling that up, Antoine, or if you want me to grab the link.
I don't even know. There's dashboards, right? But I mean, you can take a look right this second and see the maintainer. So this is all maintained, and it's all part of the there's actually votes that happen as part of the project life, where people get voted in and out as part of the life cycle of their contributions. If you go, I don't know if it's the maintainers, there's a set of requirements around what it takes to become a maintainer of Besu, what it takes to remain one. If you stop maintaining or pushing code or helping or voting on things for 6 months straight, then I believe then we remove you as an emeritus, and there's a vote that happens for that as well.
And Antoine, I'm going to drop the link to the public Besu dashboard if people want to take a look at that, or if you want to show it briefly. But Linux Foundation has what they call an insights tool that looks at not just development activity, but community activities such as chat, whatever the tools are in the community, just analytics for them. So if you're curious.
This is really good. Thanks for sharing, Dave. I had no idea that this was a possibility. I would say there's been a little bit of a creative tension on the chat side. The Hyperledger Foundation used Rocket Chat for a long time. Most recently, it moved to Discord, and it's really helped in terms of maturity. So if you're if you want to chat with developers on Besu, there's a number of channels on Discord you can join. Besu-contributors, Besu-reviews, where you can see the activity. It's a worldwide team. There's people in every geography pretty much. And so there's always someone around.
Good, that's great, especially the chats. That's probably going to be useful in the future.
Yep.
Yeah, and all that's open. No restrictions. It's all public and available for anybody who is interested.
So let's go back. We are at overtime, and I believe we had a little bit of time for folks to also join us. And so we're going to go to our next part of our workshop. I'm going to ask David as well to just drop again a little bit the rules of engagements and a link to Discord, if that's possible, David, in the chat. So
sure,
that folks
absolutely.
can ask questions.
Yeah, I can just say a quick word or two, and if you've heard this from me earlier, apologies for repeating, but for people who are joining the second half, just welcome. As Antoine said, there are some rules of engagement. Basically, we just ask that people are civil with each other, but it is an open community, which means anybody anywhere is welcome to get involved. That could be joining this workshop. It could be joining the Discord channel. I just dropped a link to that in the Zoom chat. It could be going to the regular Besu calls. It could be submitting a patch to Besu. There's all sorts of ways you can get involved, from joining discussions to helping with development, from using it. We talked earlier about how people take the code and use it in different ways, and then joining the special interest groups around different interests. So there's all sorts of ways to get involved in the community. Though, it's open, there's no, restrictions. The only thing we ask is just that people be civil. And if you have questions about the community, feel free to drop them in the chat, and I can answer those while Antoine's going into the technical details.
Thank you so much, David. This is very helpful to frame a little bit the engagement here. So I'll be on the lookout for any questions, anything coming up as I go. I prefer to be interrupted. This is meant to be interactive as much as possible. So just chime in if you have any comments, questions, or anything that comes up as part of our work today. So we're in the second part of our workshop. We just had a 2-hour workshop coming up, where we talked about Besu. We talked about how to run Besu. We talked about how to configure Besu. In this session, from 10 a.m. to noon Pacific, we'll go deeper inside Besu itself. So we're going to take a look at the code. We're going to take a look at how it's been organized on GitHub. I think the question we just had around like how we maintain community and all that is a great tee up for us to also show the life of the project. And then we'll go into actually working with the IDE. I'll share and type code away, which is pretty, as you can imagine, as a developer, always a risky operation. So I'll try to impress you with my typing, and we'll work on actually understanding how to extend Besu. When we'll extend Besu together with a new opcode and we'll play with that opcode. We'll actually generate a new Besu distribution that is using that opcode. We'll deploy a contract to it, and we'll be calling that opcode as part of this workshop. Again, throughout questions, interruptions, things you want to know, it's a good time to ask those questions. I'd rather have a lively debate and interaction with you than just type away or blabber at slides for the rest of the duration. So the slides here are a little bit more, let's say, more of like an indication of what we're going to talk about and content that you just need to read to understand. So follow my voice. Again, the French accent may get to you. If it does, feel free to ask me to repeat or clarify what I say. I'd rather you ask me than I blabber away and you're left in the daze. Again, some prerequisites. This is on the wiki. If you go to Discord, I dropped this link as well. Now, let's talk a little bit about Hyperledger Besu and development tasks. So as part of the prerequisites, I've asked you to please download the source using a git clone task so you can actually play with it, right? And there are a number of things which are really specific to how Besu performs. Besu works with Gradle. If you're unfamiliar with Gradle, I recommend you take a trip to gradle.org. If you've ever built anything in Java, especially with Maven, Gradle is kind of an evolution of that. It's a bit more scripting oriented. It's actually got some roots in maybe, I'd love to say, Apache Builder, but eventually moved down to becoming its own DSL, and has the ability to build Java, make sense of it, create a lifecycle around it, which is well known to developer. One thing that Gradle does, which is really welcome in all this, is that it has the ability to add a wrapper that is going to be local to your disk, to your development environment. You can check it in Git, and it takes care of managing Gradle for you, so you don't need to download it separately as a separate tool, etc. Take a look at that. Let's go and open the Gradle.w wrapper. As you can see, it's linked to a bash script. It's a bash script that will check whether Gradle is installed or not. If it's not installed, it will download the wrapper for you, and it will then download the whole distribution. So in Git right now, inside Besu, there's a Gradle folder with a wrapper that points to a Gradle wrapper.jar. The Gradle wrapper.jar has properties which point to which distribution in Gradle to use, and is going to use it going forward. 7.3.3, you can use Linux, you can use Mac, you can use Windows. As far as I can tell, it should work fine if it's going to be building and development. So yeah, if it's giving you trouble on Linux, you can definitely. I'm on the Mac right now, right? So I'm very biased toward Mac for all the bad reasons involving laziness and being a manager in my day job. So most of those examples and most of the work that we're going to be doing today is on a case-insensitive operating system, but with Linux properties. So Gradle itself is managing itself as part of a wrapper. When you do, when you do the Gradle W, you're actually calling this little bash script that then calls that to this distribution of Gradle. If you just do Gradle W, it will run the default task. So to avoid that, let's pick something that makes sense. With new modern projects in Java, we have found ways to kind of help us streamline development. And this is new. This is not something that was existing 5-6 years ago that easily, but now we're using things like Spotless, which will reformat the code in a way that does not invite scrutiny anymore, does not actually allow people to bicker about the format of our code, right? So it's picking tabs versus spaces, picking the indentation rules for us, and best of all, it's doing it for us so we don't have to. So we don't have to maintain on indentation. It's also checking things like, making sure we have a header for all the license, for all the copyrights, so we don't mess up and have files which are not up to date with our copyright headers. Here is an example here. And it's going to really format everything for us. So a good example is if you do Gradle, Spotless, apply, And this is in my IDE, and I'm running a terminal in my IDE, right? So just to make it simple for myself. And then you can see it's actually running. The first thing it's doing is it's actually compiling and configuring itself. So it's discovering the modules that are built inside Besu. Now it's going over each of them, and it's doing a spotless Java small task, right? So this is your first run of Gradle, and you should come back with build successful because you haven't done anything and nothing has been changed, right? And if you look at the state, if you do git status, there's been no changes whatsoever. You can do something a bit more extensive when you can do, say, a Gradle W check. So in the same way that we're using spotless to make sure that you don't mess up and you don't have inconsistent indent or rules, we also want to make sure you're safe in the way you compile and provide the code. But most of the time, there's some gotchas in Java. We've been there forever. We don't want to spend time in code reviews telling you about how to close your file or how to manage better the way you split a string. So for that, there's a Gradle W check command. This is run by CI every time you make a pull request against Besu. So what does that look like? Well, in our build.gradle file, we use something called error prone, which we configure and even extend to make sure that we are in line with the best practices in terms of development for Java. It's very useful because we just have to upgrade error prone to the latest version every once in a while to pick up new rules and to pick up better ways to develop our product. So if you don't know that and you try to make deployment or the development of Besu, you may not actually have a great time because you find yourself then in a situation where those checks might fail. So before you commit, it's a good idea to run spotless. It's also a good idea to run checks to make sure that you're in line with what is possible. Any questions about any of that? And really, I'm just using those two tasks. They're very convenient to kind of show you what Gradle is and how to run it from the command line and all that. You also have the ability to run Gradle from the IDE itself. Just don't do it out of habit of relying on the command line for everything, which is just showing my age. All right, let's go back to our deck. Close a few things. So the layout of Hyperledger Besu is laid out as a multi-module Gradle project. So most of the time when you build that stuff in Java, you don't have multiple folders, libraries, components. You usually just build everything in one place. Besu is more complex than that. It's got many moving pieces. So it's going to be built into one project, but of many modules. We'll take a look at what that means in just a sec. The same project also contains sources, but also the distribution logic. So we're going to take a look at that. We're going to see how it's being built and how the zip files and the tar.gz files are being generated. And finally, because it's one big layout, it allows us to centralize all the versions of all our dependencies into one, what we call a bill of materials or BOM. This is great because for audit reasons, then we can tell you authoritatively, hey, we're using this version of Spring, this version of Vertex, this version of yada, yada, right? So let's take a look at what that looks like in reality. In reality, when you set up a multi-module Gradle project, you would set that up into the settings.gradle. You then include all those additional modules right here as part of your Gradle config file. That's how Gradle knows to pick up in those subfolders all this information. To pick on one that is easily recognizable, we could go to the EVM folder. Let's take a look at that. And you can see that it's got its own build.gradle because it's its own module. So it's own module. So it's actually telling you, hey, I'm a Java library. Please apply the IDE plugin as well. Here is a name that you should use when you package me. Here is some attributes that you can add to the manifest of the jar file that helps identify me when it's time for me to be downloaded or used. And here's the dependencies that I have. Now you notice none of those dependencies have actual versions. right? None of them have versions by default. And then finally is publication. We can set some rules about how we want to publish it to Maven. I mentioned as well that we had the distribution logic as part of this. So in the Besu project, which is a module of Besu, we have a build.gradle that goes a little deeper inside. Oh, my bad. No, that's not what it is. That's the application itself. So, build.gradle at the bottom, we should have a distributions here for dist star and dist zip. So the publishing here of this zip is going to take all the sub projects and push them into an application, and that's part of the here we go. That's part of the actual distribution. The distributions tend to live under the build folder, distributions folder, and that's where you would see the tar.gz and the zip file. This is where we were earlier in our previous workshop, where we were running Besu. I'll just check things, it's running forever. So this is also where we create our distribution of Docker, right? So we take our existing untar, we untar the distribution that we just created, and then we copy it inside a build folder, and then we run it with our Docker build command, so we can actually generate our Docker image as part of that. So all of this is being completely run through Gradle, including creating the distribution, creating the Docker file, creating the Docker image. All those things are happening there. Any questions around that? Okay, let's move on to the next item. Version is centralized in one file. So for that, we go to the root of the checkout, and there's a Gradle folder here, which would contain all the information we want. It's got a version.gradle file. That file is actually being imported by the root build.gradle, but it's generated into a different place so that we can easily separate edits to that file from the build script. So told you it's a build dependency management, which is a build of materials, and we're about to go and discover all the dependencies of all the basic components in one file swoop. Right. So if you have any dependencies that needs updating, or if you want to see the versions that is used by Besu, you can easily go here and find everything that you need to know about the version that is currently being used. This is extremely useful when you're trying to understand, this version I'm using of Besu, does it have this particular vulnerability? That's one way to do it. Another way to do it is to go to mvnrepository.com and see if those dependencies are being listed as such. The third version to do it is to go to the distributions folder, unzip Besu, and look inside the lib folder and see what is actually being packaged in there. So taking a look, you can see, right, what is being provided here in terms of configuration is eventually what is going to be showing as part of dependencies here. Okay, so if you're familiar with Java development, this should not be too far off home. So I'm seeing compilations so we're still having a little bit of an issue here. Let's expand this. Yeah, so it seems like you have an issue with repo.maven.org not being available to you for some reason. It sounds like could not get JSON Smart 247.pom. It's interesting. Besu being a very, very big project. I believe this is a flaky repo.maven.org issue. If you want to try again to run the exact same thing, then you might get more lucky to download that, and then it will get you where you need to be. You still, it's like you're assembling build file in 49 minutes. Is your internet flaky? Okay. Miles, I hope you get there, truthfully. And so please try again if you get a chance. That might get you where you need to be. So we covered the basics. If you know those basics, now you're able to kind of run around the repository and make sense of what's going on. You just have been given a very vague assessment of, okay, there's a notion of modules and we are running with Gradle. So we can do an assemble now where we're going to, and assemble is not our task. It's not something that is special to Besu. It's actually a lifecycle task of Gradle. And we can use that to assemble our very own Besu. I believe I performed that task earlier in the last workshop. So as you can see, it's going over. It's going pretty quickly because it's already compiled all this code. It's already got all the dependencies it needs. So it's just checking that the sources are up to speed. And very quickly it says, well, you know what, the zip file does not need to even be regenerated because everything is checking out. So we're able to be smart about this, and we're just going to say the build has succeeded. And yeah, assemble, as you can see, mouse finishes in 14 seconds. I'm sorry to, hopefully I'm not making you too uncomfortable with that. And it's generating the zip file and the start zip file as well. So if, please at home, please run this as well. We'll be using that as a way to generate our very own Besu in a moment. So I need to make sure that it's working for you. If you have any questions, and if you run into anything, please let me know. The assemble phase is important because it's happening before tests are run. So it will be a lot smoother and nicer to you than if you try to run something a little more elaborate, such as Gradle build. Again, if you run with assemble, then you don't run tests, which is what you want at this time, because it's going to be too long otherwise for you to try it out. The test phase, and we're going to explain why, is pretty intensive with Besu, and that's the tie into my few next slides. So the repository is made of modules. Each module typically contains source code under source main Java. That is not up to Gradle, it's even a Maven default repository layout, right? Additionally, unit tests are present under source test Java. In some cases, we will have also integration tests. They're more rare, but they happen to exist quite a bit under source integration test Java. These are different source trees because they respond to different things. Integration tests are running outside of the inner internals of the code, and therefore are more involved and more expensive to run. But we're not done. Besu has two more types of tests that it runs every time you do a build. The first one is a set of acceptance tests, which are extremely taxing for your system because they actually run Besu. They run Besu, they may run multiple versions of Besu to kind of create a consensus algorithm between them, and actually performing tasks such as propagating blocks, making sure this works as it should. And finally, we have reference tests, which are borrowed from the Ethereum Foundation reference test frameworks using a set of JSON files that create scenarios to test for the EVM or to test for transactions and block processing. So let's take a look. Let's take a look at a simple one, such as the config folder. If you open the config folder, it's got a source folder, right? Source, main, Java. Java itself, and then you can see it's got its own package, Hog, Hyperledger Besu config, where everything else is neatly lined up and ready for you to play with. It's got some resources here, which is all the Genesis configurations that we talked about and is useful on its own. And then on top of that, it's got some source test Java, which is going to be all the tests that you want to run. We use JUnit 4 in Besu. There's been some movement towards JUnit 5, but it's not there yet. And those tests kind of look like this, right? So you can actually run them in your IDE by pressing this button, for example, run all the tests in this particular class using this button in IntelliJ. That's not different from Go, it's not different from other elements. Oh, I need to zoom in. Okay. I think there's a presentation mode on this, and it's trippy. No, I don't think this is it. Here we go. Totally was trippy. So that might be a bit too much zooming in, but this is a particular test class here where we're working on a specific test in Besu. And if you're using IntelliJ ID, you can click here, or if you're using Eclipse, it will also show that. And you can run tests right here and there inside your ID. Fortunately, that's not really what I want to show you. I want to show you this particular project as much as possible. So let me try Zoom. Nope. Well, I'll try to be as explicit as possible about the format of those folders. So if it's in consensus folder, for example, we have a few more. And if I remember correctly, we have an integration test 1, test support, integration test for IBFT. So the IBFT folder, was deemed to be complex enough that we wanted to have everything, right? We want to test at the unit test level. Unit test level. So we have all the unit tests here that test that the gossip is working, that we're able to create all the messages that we want. And at the same time, we want to have integration tests that will perform much deeper type of test where we're going to just take the whole consensus, run it, and then really get to the bottom of what that gossip does. Right, so it's really verifying between peers that we're able to see the messages we wanted to see, etc., etc. The acceptance tests are just out there. So the acceptance tests have a whole DSL that allows you to run Besu, and I'm going to pick one that I happen to have worked around recently. The open telemetry acceptance test, where we're trying to get a Besu node to run. And so here, I'll enter the presentation mode so you can see it better. So this acceptance test is setting up on the side a collector that is going to collect metrics from Besu, right? That's simple, right? And when we set up the test here, we set up first a server that is going to collect those, be the destination of those metrics. And then we're going to create a new node, which is an RPC enabled with some metrics configuration that we set here, right? And we're going to build it, and then we're going to start it as part of a cluster. So what that means that behind the scenes, we actually are going to start a complete Besu node with the configuration items set up. And we will then be able to interact with that node of a JSON RPC, for example, or by checking some configuration or some issue has been propagated properly from the metrics configuration. So in that particular case, for example, we're going to say, we're going to wait 30 seconds for this particular condition to become true, right? So we're going to say, hey, give me the metrics. And we're going to assert that we have at least received one metric from Besu. And we do the same thing with a trace where we interact with the node by sending a JSON RPC call. And then we expect that the node will then pick up from that interaction that it needs to emit a trace of a JSON RPC interaction. And then we're able, over 30 seconds timeout, to repeatedly try to execute the logic here until we see that we got a span. It looks good. It looks like what we wanted to see, etc., etc. When we do changes to Besu, we usually will cover all this type of testing because it's important for us to understand whether we're really getting the behavior we wanted or not. And some unit tests might get you to some extent some safety, but the acceptance test really proves that the feature is working as expected. So another one that is interesting is the reference test. I need to learn that keyboard shortcut to move between test and not. So the reference test from the Ethereum Foundation are the same for all the clients. And for that reason, they actually are a little annoying because they are not going to be so simple for Java developers to pick up without any work. The reason is they are stored in JSON. Oh, okay. We're gonna find it. So reference test, source, reference test. Oops. Appears that I don't have them checked out. So what I'll do is I'll go to show you what they look like directly on GitHub. By default, we do not check them out as part of the checkout. There's some module. So if we go to, let's say, VM test, if I remember correctly, looks like it's been removed. We can go to general state tests, and then we can see a good one would be, for example, stchainid. We can see a chainid.json here is what we're going with. It's a JSON file that is setting up the environment in which we execute. So it tells us, hey, let me see. Hopefully that helps you. So this zoom-in will help you kind of see better this GitHub page. In this environment here, we're saying that we're operating with a current difficulty of this much. The count base in the client is this much. We have this client with random display with hash. And then we have a pre-environment in which we say we start with 2 accounts that have this much balance, the announced, and have some code deployed even. And the other one does not have any code, but has a brand new announce and has some money. And the transaction is going to impact our state by sending no data whatsoever, but sending some information, sending some money to this new actor. So the transaction here is going to change the state and change the behavior of the client, right? Change the world state. So here it's testing it for all sorts of different hard forks. For the burning hard fork, we'd expect the hash of the transaction to look like this. We'd expect the indexes of 0 gas for data, gas, and value. That is going to be, where's data, gas, and value? Data, gas, and value are going to be the 3 impacted thing. In here, we only have 1 option. So sometimes they have multiple options based on the different calls being made. And the logs being emitted here says this is the hash of all the logs being emitted as part of the execution. And these are the bytes of the transaction. So those tests are hard. They really hurt. And usually we want to have them so we have the compatibility and interoperability between different clients. And as you can see, they test all sorts of different hard forks from Istanbul, London, the merge, all that. So to make sure that we're in compliance with the rest of the clients, we also have to run the same test. Any questions about that? Cool. Okay. So let's dive into the repository. I want to show you into the J. Try my best to zoom in. The different components and the different ways these are interoperating to each other. So let me try again. Oh, did something. So let's open Besu again. So Besu has top-level components and has components which are going to be tributary to the top-level components. A few components that Besu has had to build, and are not really related to Ethereum are things such as crypto. So the crypto component here defines how we work with crypto signatures and cryptographic key pairs for SECP 256K1, and later on with those new changes to be FIPS compliant, SECP 256R1, which is a different curve. So all this crypto work is almost like a different library, right? That happens to be part of the Besu work and then is being imported into Besu. Data types also is meant to be a independent set of types that are being used by Besu, but don't have any tie-in to the internals of Besu itself, right? There's a few more. Metrics, they're meant to be a metric system such as Open Telemetry or Prometheus, but they're not tied in to the actual Besu code base. They're not tied into the internals of Besu. They're being imported as a library. Where it gets interesting is when you start looking at Ethereum itself. So Ethereum is not a module, but it contains modules. The Ethereum API module, for example, is going to be the top module for all the interaction you may want to have with Ethereum in terms of world state interfaces and things like that. The core module is where most of the stuff is going to actually be present, and it is going to be quite a bit of Java here. Especially around like storing data, all the core quorum setup and all that. And the if module is where everything related to if itself, to the merge and the validation, the if protocol is going to be stored. So you can see already that there's a separation of concerns in the code between libraries and things which are more related to Ethereum itself and its processing, block processing, peer-to-peer agent, discovery, element like that, right? What's really interesting here is to understand that this is meant to allow you to perform with mainnet without, for example, looking too much at the permissioning approach or to look at other consensus algorithms. So even consensus algorithms would actually be a separate library which is running on its own here, and it's got all these consensus algorithms being imported into Besu core as part of this. The big hitters as part of this, the things where everything comes in, starts to tie in together, are going to be the config module, where most of the configuration is being treated, processed, assembled, validated, built into domain objects that can be used by Besu itself, and the Besu submodule. So Besu has its own Besu submodule, and that's where all the CLI arguments are going to be assessed. That's where the main method is. That's where the top level of the iceberg is present. So again, everything is being done so that the Ethereum stuff is really just Ethereum as much as possible without trying to have too much pollution from permission environments or enterprise requirements. Everything that is enterprise is going to be on the side into its own set of modules, especially things like the Enclave, especially things like plugins, which allow you to extend Besu using an API, or anything related to privacy contracts or additional services. No questions. Hopefully, it's not too unreadable. Let's keep going. So there's a gripe with Besu, which is always fun to read about. Every time I see a new committer join Besu, there's a honeymoon phase, about a month or so, where people are like, wow, Besu is so great, so much complexity, so much to do. And then we give them a job to implement a new service or take an existing service and tie it into a new component. And then we hear it. We hear the incredible gripe that people develop when they realize that Besu is a tie of knots and a bowl of spaghetti that's been left too long on the kitchen counter. It's a lot of moving pieces. It's not, frankly, anyone's fault at this point. It's just that there is a ton of configuration and options that go into building such a complex software stack, between normal configuration options that you would want and also the complexity of all the hard forks of Ethereum compounding on each other. We see a lot of complexity. So I'm about to show you something that may want you to peel your eyes off. I'm not proud of it, and I believe it's important that you understand it intimately so you know how to contribute to Besu, because that's where most of the innovation is kind of stuck. So before I do that, there's a pattern that is used a lot inside Besu itself called the builder pattern. It's a design pattern of sorts. What it allows you to do is that instead of creating objects directly by passing elements to the constructor, you can create an intermediate object that you can configure to eventually build the final object. And so you'll see that. I'm going to show you an example of it. I want you to keep your eyes like wide open on that. It's an interesting pattern that's used throughout Besu. It creates some indirection, but it also allows you to validate whenever you want to create the object before the object itself is validated. So the life cycle of validation and checking that the object is being built properly is kind of left out to the builder, and it's not polluting the life cycle of the object itself. Okay, let's go take a look at the Besu controller builder. So I'm on Shift-T, Besu controller builder, and then I'm going to go into the implementation mode. So the Besu controller builder is extremely important to Besu because it manages all the components that are going to be used as part of running Besu. And it's building a Besu controller, if you could tell. So it's getting all those components in the right place, and then it's going to build the controller. By default, you can see it's got a number of protected fields, which are not final, meaning that they can be set later in the lifecycle of the object. And it's got all these nice little DSL methods, which says, hey, storage provider can pass it in, set it, return this, right? Return this, return this, return this. So all these configuration aspects, all these configuration elements can be set and be used as part of the DSL to work with the Besu controller builder. At the bottom of the file, once you've passed all this, you can see the build method itself. The build method is used to check that you're building correctly the domain object that you wanted to build in the first place. So it's doing all sorts of interesting checks, such as, if it's null, then there's not going to be a good Besu controller. Therefore, we need to make sure it's never null. The next thing it does is that it's going to create from a information configuration that's been passed to it, additional domain objects that are required to make sense of in the Besu controller. So, for example, you're getting a factory to create a world state, meaning you are going to wrap around the RocksDB database into a thing that is able to read it and make sense of it and gives you an API where you can access accounts, for example. Well, the storage provider is going to create a world state using the data storage configuration and give it to you. Same goes for the blockchain storage. Then you're able to assemble together a blockchain, which is going to be made of a world state and its blockchain storage. Then you can have the archive, etc., etc. So all this information, all this plumbing has to take place as part of setting up your client, right? Once we're good to go, we can create a transaction pool, if protocol manager, a synchronizer, which is responsible for talking to other peer, a mining coordinator for using proof of work. We are going to create this humongous object called the Besu controller, right? It's going to have a protocol schedule, an if protocol manager, a sub-protocol configuration, a synchronizer, a sync state, transaction pool, mining coordinator, privacy parameters, mining parameters themselves, etc. When it's time to then close Besu, this Besu controller can then close all the services in the right order to make sure that we're not getting ourselves in trouble and we're not abandoning, for example, a half-mined transaction or something like that. So there's a lot of those in Besu, and there's a lot of spaghetti code that has to deal with the complexity of all those things coming together. Why are they so intertwined? It's because of the nature of Ethereum itself, nature of the work that we're doing with Ethereum itself. We could use dependency injection with Spring. We talked about that, and frankly, didn't come out the other way. That completely, convinced by it. The reason is we would not actually abstract that much complexity because of the way it's all intertwined together, and there's still life cycle issues if you don't pay attention to things. Instead, passing explicitly items and checking that they're valid has been helpful to keep sane when we're working with our code. Any questions about that? Okay. I'm going hard at this, and it's just the beginning. So we're going to keep going on that. Which folder and or file are we in? We're inside. Sorry, Zoom getting in the way. We're inside Besu Controller Builder, which is under Besu source main Java org Hyperledger Besu Controller Builder build. If you want, I can copy the path reference. I'll do that from the repository root, and I'll do that and share it with everyone here in the chat, and then if I can paste here in Discord as well. So this class is so important, right? It's where everything kind of comes together, and you can see all those domain objects and all those different actors playing together to play around. Okay, and in the same kind of place, we also have the Besu command. So Besu command, which is kind of the origination of all the configuration, because we have to run and get all the command line arguments and read the config file, read the environment variables. All these plays together as part of the CLI in the Besu command, which is where you would start and then get all the options and start working your way down to build all those elements. If I open the structure and outline of this class, I can see, it's doing is creating the builder in the first place, for example. Whoops. It's building the builder in the first place. It's setting all the builder configuration that we just saw based on the configuration that's being passed to it. And then the run method is where it eventually, after binding and configuring everything, it starts it starts the runner, which is going to be responsible for running Besu itself. So understanding this lifecycle, understanding how it comes together is important, but it's also interesting to understand that when you build the builder and you have also domain objects, those domain objects are part of those libraries, and they may not be aware of each other as much. So we need to be careful in terms of class path and dependencies that we don't have domain objects depend on each other in a way that would introduce conflicts or, Jack was reporting that the Discord invitation didn't work. David, would you please help him out? Okay, we'll get David to help in a second. Okay. So we've been scrolling through. Now it's time to also show you another example of shared concern where we have many things coming together that seem completely unrelated, but yet have to work together to make sense. It's called the fork ID manager. It's used as part of the status message. So when I talk to other clients, I'm going to tell them, hey, I'm currently executing on this Genesis configuration, but I'm up to this fork ID. And the other client will be able to tell you, looks like we agree that we're on the same fork ID, but therefore we're able to work together and continue working together on synchronizing each other. Or I don't know you, I have no idea who you are. In that case, you need to disconnect from me. So the fork ID manager. Whoop, why am I? Hang on. The fork ID manager is a class. So I go from class to class using Command Shift T on Mac, Command Shift R. It's possible as well. Now I'm going to post the slides in a minute at the end of the workshop. We haven't shared them yet. And the fork ID manager itself, as I mentioned, is responsible for building and representing the latest and greatest in terms of which fork I'm on. In terms of forks, let's take an example of what a fork and what that means. So a fork, for example, would say, at block 0 for Robston, I was on that particular fork. At block 10, I started being on that fork. At this block, I was on Byzantium, etc., right? So as if you're, let's say, or after Petersburg, you'll be able to say, hey, I know about up to this, right? Up to this particular fork ID. So to do that, one of the things that has to do is to know what's our latest head. And the head is, it's the latest block that we know about that is deemed canonical, meaning it's not going to change. And to do that, we're going to use this function on the blockchain object, right? But we don't keep the whole blockchain object. We use this lambda notation that allows us to keep a handle to the method itself without having to keep the object around. So here we pass this blockchain object and we keep the chain ID's head supplier. Then we perform all sorts of interesting things around the Genesis configuration. Using the Genesis block, we get all the fork block numbers that I just showed you for Robston. Then we compute using checksum a set of hashes that we can identify where we are in terms of those forks. And whenever we check a peer connecting to us, we check whether if there's no forks whatsoever, we can drop. What I'm gonna do is again open the connotation mode here. So if there's no forks between us, we're good. There's no need for us to check anything. If we don't know that hash, if you have no idea who they're coming from, then it's not good. If our chain ID supplier is less than a fork next and is a known fork for that one, and if we're aware of them, then we're good to go. So what we end up having to do here is, even in our network communications, we constantly have to know where we are in terms of our own chain head, right? And this changes every certain seconds whenever we have a new block coming in, or if we're synced up, right? So we have to continuously keep asking the chain ID head supplier for the latest block that it's aware of. And then when we create our own forks, we will be asked of that. No, actually, that's not it. So we will be asked for this fork ID for chain head every time we connect to other peers, so we can send them what we know about ourselves. We'll be getting the latest block number. So exiting a little bit this mode. If I go to the fork ID manager, I'm a little curious. How do I actually get myself created? So we're getting stuff created in test, sure, but we're also getting created in the main. Looks like we're being created by passing in the blockchain here with no non-forks as part of this, and this is visible for testing. Okay, how about the other guy? Now we can see the blockchain, the forks, and our wire protocol configuration. Are we using the ETH64 fork ID or not? So the ETH protocol manager itself, now we can go back, we can start looking at it and say, okay, in our Besu controller builder we were looking at earlier, we're going to create our own ETH protocol manager. And again, we're passing around the protocol context blockchain, the non-forks, the wire protocol configuration, etc., right? Genesis config.forks at the end. So as you can see, all those objects are, again, intertwined and coming together and making sense of each other. Okay. While people find their way to our Discord, let's keep going. So I'm going to discourage you a little bit here, even more, by showing you a little bit of how complex and involved it sometimes gets when we have to work with consensus and we have changes that impact everything with Ethereum, from the EVM and DOFs codes. That's well known, where folks go like, oh, you added create to, you added this new opcode, that's awesome. Yeah, that's not the only thing that changes. Whenever there's a hard fork, you may see changes to how we sign transactions. That's EAP 155. We may change the way we want to reward miners for mining blocks. So that's a furthering, for example. We may want to change the way we mint blocks. So maybe we want to change things as simple as the extra data, or we want to change the base fee to be involved in the block minting. We want to have change in the way we do transaction pool fee calculations, and more, way more than that, right? So protocol schedule is going to help us make sense of that. And let's take a look at it. A protocol schedule allows you to see a protocol spec, right? So you may have, say, from block 0 to 1000, I'm going to behave with that spec, and then I'm going to change that, etc., etc. So the protocol spec, and I can open that in presentation mode, has the ability to really completely configure every aspect of how things work inside the protocol, from the way we're going to calculate gas, to the way we're going to calculate the limits of the gas, to how we validate transactions, to how we process transactions, to how we validate block headers, etc., etc. So the block rewards, the difficulty calculator, everything here is up for grabs, right? Pretty much. And as Ethereum has matured and went through many hard forks, this complexity has just been a runaway train, where we're adding even more, configuration aspects to it. So the good news here is it doesn't have to be too overwhelming if you're working in a straight line and you're just adding one more thing to your protocol spec. So we can go to the mainnet protocol specs here, and I'm going to open the outline here. So the first protocol spec is the frontier spec, right? The first one that was ever created. And it says here, protocol spec builder, we're going to use gas calculator or frontier gas calculator. We're going to use all sorts of interesting things. We're going to build a EVM using frontier. We're going to use a precompile contract registry builder here, right, for the precompiles on the EVM. And then, we see all the configuration of that. Now, the good news is the next one, which was Homestead, if I remember correctly, takes on the frontier definition, passes in almost the same configuration, and it says, oh, by the way, no, change the gas calculator and use mine instead. Change the EVM, use mine instead. Change the way we're going to do contract creation, use my approach instead. Change the way we validate transaction, change mine instead, and name it Homestead, and so on and so forth. So if you're looking to understand how Besu is going to stack up all those protocols, those hard forks, this is the place to be. Mainnet protocol specs under Ethereum core, source main Java, or Hyperledger Besu Ethereum mainnet protocol specs. So if you go to the end to kind of play with the merge, we see that there's a Paris hard fork, right? And the Paris hard fork is actually building on top of the Arrow Glacier definition. So the Paris hard fork seems to be adding new EVMs, a new EVM with new opcodes. Okay, cool. The Arrow Glacier definition on the other side is changing the difficulty calculator to use the Arrow Glacier difficulty calculator. Okay, no problem. Then it goes and builds on top of London, which changed a few things. They added a new fee market to change the way we market transactions, change the way we allow contract size limit, etc., etc. So it's, and then itself is building on top of Berlin and so on and so forth. Any questions about this construct and how it's built? Hopefully I didn't lose you there. We're going to change this file in a few minutes to add our own hard fork. I hope you're ready for this. Okay. There's a stunned silence. I didn't mean to do this to you folks. I'm sorry. Hopefully, I didn't put you to sleep. And just wave in front of your screen if you're still around. I can't see you, but I can feel your karmic energy. Yeah, we talked about protocols. We talked about all the specs. Let's take a look at mainnet EVMs too, right? It doesn't hurt anymore, right, at this point. So the EVM itself is a different library because it's been moved out into its own configuration, so it could be used by other projects such as a header hash graph, right? If I go and enter the presentation mode, I can see the exact same approach and construct as you would expect from what we just saw with the protocol spec. Oh, got a question. Okay, Christos, I'm glad you're here. So if you're not at all familiar with EVM, it's got a number of operations which are defined initially with Frontier. You can see things which are more like arithmetic-minded, add, mul, sub, div0, sdiv0, mod, smod, x, d0, all those things. You can read the yellow paper to understand better what they do, or you can also just check out the Besu source code and open one of those operations to have fun, and we'll do that in a moment. So all those things are part of the default set of Frontier. We add push operations, dupe information, swap operations, log operations, all those things. For Homestead, we are just changing the gas calculator. We're not adding. We're adding one. No, we're just adding the delegate call operation in Homestead. Okay. For Spurious Dragon, I believe we're just calling Homestead. There's no changes in Tangerine Whistle, calling Homestead. Byzantium, oh, we're adding something again. So we're adding the Byzantium operation for return data copy, return data size, revert operation, static call operation. Crazy, we didn't have revert back then. Constantinople, we had Constantinople operations, and then we registered them as well. So we have create2, which was very popular back then, SAR, shell, SHR, Xcode, hash operation, all those things. Oh, I'm getting some chats. Okay, looks like people are in a good state. So now we can see how those combines, and again, right? It's an aggregate set. We're not removing anything, because if you start removing something from a prior set, you may actually get yourself into a lot of trouble where you break consensus or you break a backward compatibility. So most of the time, what we see is additional elements that are being added to the spec itself. And so we register all those operations. We can go all the way down to Paris, and we can then make our way back if we want to, where we say, hey, we're going to register Paris operations, meaning register London operations, but then we add the previous Randao operation, for example. Okay. So that's how we actually compute everything that goes into the EVM. And not really, because I'll show you what the add operation looks like, so you can take a look for yourself. The add operation has a bytecode that identifies it on the chain whenever you look at code from EVM. If you see 0x01, that might just be the add operation. It's consuming 2 items from the stack, produces 1. It's got an upsize of 1, meaning it's consuming 1 bytecode from the code when it executes. It's got a gas calculator, and by default, it's a fixed cost operation here. So it's using the gas calculator, get very low tier gas cost, which is either 3 or 2 gas, depending on which hard fork you're on. Yes, that changed too. So to execute this fixed cost operation, we're going to take from the stack 2 items that we're going to convert into a big integer, because they may actually be up to 32 bytes of data in there, so they may be really big integers. We're going to add them to each other, and then we're going to have to deal with the fact that maybe sometimes when you add those 2 integers, they overflow past the word size of the EVM. If more than 32, then we're going to cut it so that it's back to 32 bytes. Otherwise, just wrap the result array into bytes and then push them on the stack to be used by the next operation. If you have no idea what the EVM is, it's a good time to start screaming at me. Otherwise, I'm just going to go even harder at this. So tell me to stop if you need more clarification of what the EVM does and how it works. Okay. All right. So the EVM, right? It's a registry-based virtual machine itself, right? So when you execute the EVM, you have access to a few constructs. You can have access to a stack, which is a set of operands which have been added to and they can be either pushed or popped, not much more than that. I think some operations can get values without interacting with the stack, without actually depleting the stack, but most of them do not. And they work with the memory as well. So you can actually choose to offload items to memory, and some particular opcodes will only read data from the memory. But they will take the data from the memory and then return it. I'm going to maybe show you a little bit what I mean through an example. Actually, for this workshop, I built a contract that we'll talk about in a second. And if you look at it, that's what it looks like. So this is using a DSL, which I built in a separate project called Apache 20. I will not bother you with that today. But for example, here we're saying, hey, push 0 into the stack, meaning go and push the value of 0 into the stack, then call this particular operation called call data load. And call data load is going to take from the position in the stack 0 up to 32 bytes from the input that is being passed into this operation. Then call our custom opcode, which is what we're doing today, and push a jump destination of 0x11 that may be used down the road to go to the jump dest. So if custom returns 0, we keep going. Jump I says, yeah, I'm not interested by this, or else go to jump dest at byte 0x11, right? So this is an actual real program of the EVM being built using a DSL in Kotlin that allows you to generate the bytecode for your particular program that's going to execute on the EVM. And that's what it looks like, right? 60 being push 1, 00 being pushed, 35 is call data load, F6 is our custom opcode, etc., etc. So we're going to play with that, and this is kind of an exercise that we'll do together. And this is what an actual EVM execution looks like if you're able to peel off all the layers. If you want to see an execution of the EVM, you can also run Besu in trace mode. And then all of a sudden, every time there's an execution of a contract, you'll see every state of every change in the stack and in the execution go through and be actually exposed so you can see what's going on. Okay. So it works in frames, meaning that you also have the ability to have calls between different contracts, which is what people have been calling money Legos for DeFi and stuff like that, right? So you can have APIs where you say, hey, you can call my function to kind of get the current value of this particular asset, for example. And you can, when you do that, you actually pass them to a frame where your stack is being passed in. Which is it, the tracing tool? What's your question, Christos? This Besu workshop, this code here is some DSL that I built on the side that allows me to create custom EVM code that we'll use as part of this exercise. Oh, to see the EVM execution, there are 2 ways to do this. You can use the EVM tool. You can also use a Go Ethereum EVM, which I believe is installed whenever you installed Go Ethereum. So let's see if it's on here. I don't have it on this computer, but you can install it using Go Ethereum. There's a way for you to run the EVM tool, and it takes then in terms of arguments, you can take some EVM code, some input, and even some state, and lets you play with changes to that state based on how the EVM executes. if you're interested by that all, really quick search should turn up this EVM tool reference here. And you can see, right, you can say, okay, I want to run this code. I want to set some price for that code. So you can run out of gas, for example, or you can, have an account where you see, hey, am I using all the money in the account? And you can set the standard receiver, the input, that's super important, the value, because you can have transactions actually will pay money to a particular target as part of the execution of the contract. And yeah, it goes too deep for me now. It's like the JSON and Genesis path and all that stuff. So you can really debug EVM code using this EVM tool reference. So yeah, that's the working frame. One more thing. I'm going to show you the JSON Rpc server and how it's working together. It's a nice little construct because that's happened a lot, right? We had to kind of assemble and extend our JSON Rpc over time. So there's a method for that called the JSON Rpc methods factory. It's right here and there. So JSON Rpc methods factory has the ability to add methods using the namespace that we talked about way back when we talked about the different APIs that you can enable. Go blow this up. Okay, so some of them are going to ring true right away. Some of them are more arcane, but the one that is most well known is the if namespace, which you use to interface with the chain and make sense of what's going on. So the if JSON Rpc method here, as you can see, is being passed in a number of domain objects and things that you will need to answer questions. A good question, for example, is, are you syncing right now? Or are you up to the top of the chain? What's the latest block, right? So blockchain queries is going to be this model, this object that you will use to answer queries against the state of the blockchain. The if JSON Rpc method itself is just a builder where you ask it to create methods. It's going to tell you, hey, if block number, see, it's passing blockchain queries, for example. I want to see if get code. Well, you can pass blockchain queries, and looks like someone thought through the fact that maybe you don't want to expose all the code from everyone, right? So there may be some privacy parameters in the consortium where you wouldn't want to share that. So if you go to if block number, which is a benign one, not too big, you pass in this and stores it as a blockchain here. And whenever there's a request coming in, the value of the current head is being looked at, and then is being returned as a quantity, meaning it's being encoded into a hexadecimal format, unless it's been told to be returned as an integer at all times. By default, it's not used as an integer. So this is how we map out all those methods, and it's nicely done because then it kind of removes all the crafts of dealing with HTTP and all that. And it's just dealing with JSON Rpc specific constructs. So for example, what I mean by that is you're not returning 200 with a JSON, you're just returning an object which has everything figured out for you, so you don't need to think about the details of it. Any questions about that? Cool. Okay. So here's the exercise today. And it's a hefty one. I got 45 minutes to do it with you. I happened to have it done last night. If you want, you can cheat, run ahead, and find on my fork of Besu the workshop branch, if you're so inclined. But otherwise, you're gonna have to suffer with me, and I'll give you the reference to the code at the end of that. Here's the spiel. Here is the business view of it. Your manager popped into your cube one day and said, hey, I really want to have a new way to guarantee that no one is using our permission network. And I had this great idea when I was taking a shower about using a shared secret that will be executed against all the clients. So clients that don't have the right secret will not be able to get the right answer when they execute. So for that, we're going to create a new opcode that is going to take a shared secret and is going to check whenever the stack has a value, if that value actually is equal to the hash of that shared secret. We're going to allow us to also set that shared secret over JSON RPC. And we're going to all make that work using Besu as part of this exercise. And we're going to actually deploy a contract with it and run it against the chain and make sure it's performing as it should. So I'm going to take this as far as I can, and we'll see how far we can take this with a number of objects. So the first thing we're going to do is we're going to create our very own opcode, right? We're going to create an opcode operation that checks the first word on the stack. The word is salted. No, actually, that we're not doing that. If the word equals a parameter pass in the opcode operation, reply 0, else reply 1. Oh, I'm going to say, yeah. That's better. So let's go and do that. So our add operation was up there in the EVM itself, and we're going to add our new operation here. And it's going to be called the shared secret operation. I don't want to add it to get to this point. I'm going to extend fixed abstract fixed cost operation, which allows us then using command 1 in IntelliJ to add additional parameters. And also it's going to ask me for a super call, so call to the super class. Sorry about that. So here, the idea is we shamelessly steal from the add operation. We copy here. We're going to call it a shared secret. Not that it matters, right? This is just a name that we use for our stuff. We're going to consume exactly one stack item. We're going to produce exactly one. Our up size is 1. Oh, we need a gas calculator. So we'll need the gas calculator, and then we'll get we'll just assign ourselves the cost that's always the same, very low. We don't want to disturb anybody, right? So our code is 0x01. That's the same as add. That's not going to work. So let's do a quick cursory Google search about EVM opcodes. And if you look here, you'll see that a bunch of them are used, but some of them are unused. So FB, FC are marked invalid. I don't see anything around F6 here. So we'll use F6. So 0x F6. Here we go. Now, when we talk about this executing this operation, one thing we want to do is to be able to say that we have a shared secret object that is working with us, right? So we're really missing something here. We're missing an object that we can use that would be usable for this. So what we're going to do is we're going to add a supplier of bytes, even bytes 32, frankly, which is going to be our shared secret supplier. And we're going to store this directly as our shared secret supplier. And create a nice little field right here. We're going to import this class as well, and we're going to import the supplier class as well. So first thing we do is we're going to pop a stack item. That gives us a item here that we import as well. And very simple, right? We say if our shared secret supplier get equals item, then what do we do? We push to the stack a uint 56 of 1, else did match, too bad, we're going to push 0. So I used uint 56 of 1 because it's known to be a byte 32 object, and it's all good. It's working with what we need to do. And 0 is actually a byte32 empty, right? So now I'm going to return operation result. Oh, you know what? I really don't want to think this through too much, so we're just gonna paste that. Yeah. And that's our success response. That's it. We just finished. Good job. Everybody give yourself a clap. We got our opcode. Yeah, not so fast, right? Now the hard work starts. First off, now we have passing this. And now we notice that this is in gray, meaning it's not used anywhere. It's never used. So now we have to do a little bit of work to actually make sure that it's going to be used by our EVM. How do we do that? Well, I guess we're doing our own EVM schedule, huh? So I don't want to take Paris because Paris is after the merge. It hasn't taken place yet. How about we do our own workshop operations? So I'm going to do this public static EVM workshop, right? We're working with our workshop here, right? So I'm just copying this. Boom. But we're not calling Paris anymore. We're going to call an operation registry. Oh, yes. So we're copying this and changing it to workshop here. And that's what we're calling. We're still using a London gas calculator, no problem there. And then we're changing this to workshop operations. The workshop operations, very simple, more copy paste. We create this, we register workshop operations. You're getting the gist of it. And when we register this, we copy that back in method. And then instead of registering the pre-render operation, which we don't know about, we don't care about, right? That's fine. We're going to register our shared secret operation. And note it's getting red because now we also need the supplier. So the supplier itself is going to be final supplier bytes 32 shared secret supplier. And we're going to import that. And then it's going to trickle up to this, which is going to trickle up to okay. What else is new? Oh, let's make this a public structure, and then everybody should be more or less happy now. The workshop operation still doesn't like the supplier, so we're passing that around. Now, if you're already tired of this, let's do a thing here where the EVM configuration is going to be extremely helpful for us. The EVM configuration here is a number of domain things, so maybe it could also pass a supplier. Shared secret. Okay, and choosing violence on this. So now we have changed our configuration so we can pass an additional field, which is going to be also passed in through the constructor of this configuration aspect. And now it's being finalized as part of that. So we cannot have issues later. Final in Java means nobody can reassign this particular operation. So in our mainnet EVM, we can stop the bleeding in a way by saying, hey, hang on. We don't need this. We're going to do EVM configuration, get shared supplier. Cool. All right. Done, right? So then we have this. Looks like we need a default one. the default version, which is going to be bytes 32.0. So here we create the shorthand lambda version of what a supply would look like if we don't provide a shared secret operation. Okay, so now we chase the problems one layer up, right? Now we have the EVM configuration, and somehow up the hill, right from there, we know how to pass in the shared secret. Now let's go and do a turnaround. Like I want to do this, but on the JSON RPC method factory. So I really like this idea of having a part of the if namespace, which is probably sacrilege to most people who work on Ethereum. But let's add our own operation to this. Why not? And one thing we're going to do is add a new if set shared secret to this. I don't need the blockchain queries. I do need a shared secret holder for this now, because now I'm about to set this. So I'm going to create the shared secret holder. I'm going to imagine that it's being passed in. So to make it passed in, it needs to be here. It needs to be here. And you're starting to see a problem, right? Now we're playing plumbing. So I want this shared secret holder probably to be an actual object so that I can set it, so I can also get the value from it. And so we're going to create that as a private final shared secret holder. Shared secret holder. Now I need to create this. I need to create this object in a very particular strategic place where it's easy for people to find it. Where could I do that? Let's see, maybe in the API object. And so for that, I'm going to go to outside of the EVM. I'm going to go inside. Here's the API. I can probably build this in core. And let's see if it resolves. Let me see. Yeah, so we're going to create our very own new package. We're going to call it shared secret. We have no shame of taking some room for ourselves here. And then we're going to create the Java class called shared secret holder. So the shared secret holder, I don't want to try it to anything yet, is going to be a public class, absolutely. It's going to have a public little constructor, but we don't do anything with it, right? So we're going to have it also have an atomic reference to a byte 32. So here I'm going to create a private final atomic reference byte 32 ref equals new atomic reference. Okay, byte 32. All right, we don't need that anymore. We can simplify this. So now we have just one field in this class. When I ask for shared secret, I can just return whatever is stored in the ref. When it's set, though, I don't know what I'm getting at. So let's see string value of it, for example, and we're going to do sleeve.ref.set, but we want to byte 32. So we want to hash this value. So it turns out that Besu has a way for you to hash stuff that's really convenient using a hash method and static. So we can hash this, but we need to wrap it into a byte object. So we're going to wrap that, and we're going to take the bytes of the string using the UTF-8 encoding standard. So now we have a way to set our shared secret. We have a way to get our shared secret. We have a ref to it. Now let's go and set that. So we're going to import that class. It's not being imported. And well, oh, hey, I think I forgot something. We don't have a if set shared secret method yet. So let's go and create that in our methods. If set shared secret add. I really liked earlier we were looking at that block number because it gave me everything I ever wanted. So we can do things like copying this. Actually, yeah, let's copy everything. And now we arrange a few things, and we remove this mood class here. We don't need the blockchain, no result. We need our shared secret holder. That's going to be our shared secret holder right here. We don't need two constructors, so we can send that. And we're going to save this folder on our as a field inside our method. So our shared secret holder is definitely going to read the context and try to understand what's what. So to read the context from a request, let's say if submit hash rate might give me a way for me to understand a required parameter from string. Okay, that sounds great. So we're going to use this method here and say, hey, I want the first parameters to come from this request, not to be an hash rate, but be a new shared secret. And now I'm going to set that on my shared secret holder, right? So I set this new shared secret, and I'm going to just return, we got it. So if you were to call this method and it's bound properly and everything works, then all of a sudden you're able to set the shared secret. And it's still giving us trouble because it needs to be imported, and now it's been imported, so now it all makes sense. Okay, now we have this set shared secret. It's passing this magical shared secret holder. Guess what? Everything else is on fire, right? We forgot something. We didn't do any plumbing here. Oh no, oh no. Okay, so shared secret holder getting passed in here. How can I pass it in? Oh my God, let's go and start playing the game of passing the hot potato. And those methods here are being called. You get the gist of it. In the runner builder itself, which is going to want to see also a shared secret holder. And the shared secret holder here is going to be part of our little method. Boom, boom, boom. See, like it's finally appeasing itself, right? But then we opened up 4 different places where it's not liking it. And it's not liking it because now it's building the builder. It's building the builder in different ways, different places, and there's just nothing we can do about it, but just bite the bullet and make sure we're able to get to where we need to be. So thankfully, there are some stuff in there like the metric system, things like that, which are actual field of this. So what we're going to do is we're going to say, hey, the shared secret holder can be set on the builder of the runner, right? And then we need to just add it every time we go. And then we keep doing it. Notice I don't care for indent, I don't care for how the formatting works, because I'm going to run spotless before I commit, right? Hopefully, if I don't forget. Then it will take care of reformatting the code in a format that is bearable for people to look at after I'm done. Okay, so my shared secret holder is great, but it's not actually mapped to anything at all. So now it's time to roll up our sleeves and add it to the runner builder here. So, and then we do this shared secret holder equal holder return. Now we have this done, but we don't know where this is called. That's really awkward. Let's find a usage of that. So looks like it's run as part of the thread Besu node runner, which is for acceptance test. Oh, don't want to touch that, right? Not now. We're playing with code here, but maybe we can use that as part of synchronize, for example. In that case, we can do, and then we pass in a shared secret holder that somehow we should have by now. And to do that, we can look at, for example, a private final RPC endpoint service is looking good. So maybe we can do the same thing. Now it's final, which is a grace, a saving grace in a sense. We can actually see whether it's going to work or not, right? So it's not going to work here because it's not being actually instantiated as part of the constructor of the Besu command. So one way to do that is now we're going to find usage of this other component here, and we're going to look for when it's being created. It's being created in the constructor of the Besu command, which is great. So now we can do that. Ta-da! All done, right? Right? Nope, not in the slightest. Now we have to build from our EVM a protocol to make sure that it's actually being using the right version. Who wants me to skip the line and get to a finished state? Or do you enjoy seeing plumbing? All right, I'll keep going. So remember, we got our mainnet EVMs and we defined our workshop EVM, which is our very own EVM with our own opcodes, own ability. That's awesome, right? Finally, Ethereum is ours, and we can just print money all day, right? Okay, how do we do this? They must have thought of some security settings, right? Gosh, yes. Antoine talked about protocol specs, right? So the mainnet protocol specs have told us that there's such a thing as a definition by which you will abide. You will not just create a bunch of opcodes on your own, you also have to tie them to hard fork. So for example, if you look at the Paris hard fork, it should be at the very bottom. I'm getting my way here. The Paris definition here is actually going to tell us, hey, I'm actually going to use the Paris EVM. So gosh, I guess we're up. We have to do the exact same thing. We have to do the exact same thing for our own workshop definition. We're gonna call it the workshop fork. I mean, I don't know if it sounds awesome to me, but you do you. And we just replaced the Paris with our own awesome version of the EVM. It's got its own little definition here. And we can see nothing's calling this. So did we use it for nothing? Almost. Let's see, where is this Paris definition being called? It's called in the mainnet protocol spec factory. Awesome. Let's do this. Let's just rename a bunch of things. And it's called the workshop definition instead now, and still not being called. Oh no, we just walk way up now. There's going to be such a thing as creating a workshop definition that's going to be assigned with a workshop block number. Okay, but this is not going to just go away on its own. That needs to be implemented. So to be implemented, we need to implement it as part of our Genesis config options, which I've been bashing you on the head about as a way to configure Ethereum clients, right? So now all of a sudden we have to do this, but look, it's not being implemented in the classes. So now this is starting to fail. Let's take a look what that looks like. This is the Paris block. This is my workshop block number. How is that workshop block number going to be fetched? It's going to be fetched from the JSON file by looking for Paris block. That's not what I want. Okay, so workshop block it is instead. Note it's case insensitive. Also looks like they got overboard and they were to have different ways of looking at the Paris block. Maybe it's a pre-merged for block. I don't want that. Yeah, no, they're not going to be both here. And yeah, maybe we just return that option long. Do it. Okay, and now so good, right? Should be able to run this, and it should give us a Genesis file where we can play with the actual workshop, and everything is ready. Let's do one more thing. In the Besu command, I'd like for us to have a way to set an initial shared secret using the CLI argument. So for that, I'm going to go to the EVM options. And if you notice, something is not quite right here. It's not actually compiling. Guess what? We forgot the supplier. Oh, silly me. Okay, so what does that mean? That means that this EVM configuration is no longer going to be able to be built here, because if we were to build that here, we would need to involve ourselves with a shared secret holder, which is not a good place in terms of decisions to be made, right? So what we're going to do is we're going to create an EVM partial configuration class. That will not add to Git, and it's going to copy the EVM configuration, which is incidentally not part of CLI. It's part of the EVM, so it should not know anything about shared secret holder or anything like that. We're going to make it super simple here. There's no such thing as a default for that. There's no shared secret, and there's no supplier. And this is not the right name. Okay, we remove this. And before you know it, we have our EVM partial configuration, which is now being dealt by the EVM options class, which is going to be here and stored right here. Okay. Oh, wait. Oh, I forgot something. No, we're good. Let's click again. Oh, it's because this is a generic class and it's looking for the EVM partial configuration to be returned. So we just kick the can a little longer, right? Okay, so now I'm going to set up a command line option that's going to be secret, just only for us. And I'm going to name it the shared secret command line. So I can paste that, or you know what, I'm gonna add that sheet, and I'm going to copy this and paste it here. Okay, so we got a shared secret. It's being set as a string. Notice it's never been assigned. It's actually assigned through Pico CLI, which is a library that is being used by Besu to set up the arguments. And the shared secret itself is stored here. What we're going to do is we're going to call it. We're going to just set it as a string in here, so we don't defile this object. And it's going to be its initial shared secret here, here, and then we create a field for that, and then we got it. Okay. Now in my Besu command, everything should be on fire, because we're now playing with the EVM options a long way, and I'm starting to see a little bit of an issue here. So now we can do this. We can do new EVM configuration, where I'm going to take, I'm going to take the EVM partial options first. Now I'm creating this domain object for it. And I do, I believe it's kilobytes, and the EVM configuration also wants us to pass the shared secrets holder, and it doesn't want the whole thing, it just wants the supplier. There's one more thing that we need to do is we need to set in the when we generate the shared secret holder, we want to also set its initial value. So I'm going to look for where it's used. We're going to look inside this Besu command right here, and then we're going to say this shared secret holder, set shared secret, get these double EVM options to domain objects, get initial shared secret. Beautiful. All right. So that was a lot of plumbing, right? Less than an hour. I made it. I made it happen. So let's cheat a little bit. We're going to move the next 10 minutes to actually test this new opcode. And we're going to run it with a curl command. We're going to be able to interrogate the chain and make sure it's working as it should. So in the terminal, I'm going to change my current branch. I'm going to, if I do a git st git status, I see I built a bunch of code over the last half hour, interestingly. So what we're going to do is git stash as much as possible of it, and I probably going chapter. Remove this, remove this, and remove this, and let's do a dash. All right, on that. Now I'm going to work with a workshop branch, which is on my fork of Besu as well. And we're going to do a Gradle W sample. So in this new version of it, right, VM partial configuration is still there. We're still setting the initial shared secret. You can still see the shared secret operation that I just built. It's very much there. The only thing we change is we're going to add a bit more information about what's going on, which is useful for our testing and for us to verify that everything is used. And everything else is the same. We even have the if set shared secret operation, which allows us to set the shared secret. And I forgot to show you, is going to be exposed under the if underscore set shared secret JSON Rpc method. Now we're combining, we're merging, we're regenerating the zip file for all the stuff that we've done. And as you can see, it's compiling all the elements that have been changed. Not all of them, most of them have been kind of impacted. Some of them, such as consensus algorithms, I didn't touch them. We should be able to fly through them very quickly without having to recompile all of them. And now we're building our distribution using our zip. Here we go. We're building the EVM tool that we mentioned earlier as well as a zip file. It's a separate distribution. And now maybe to make it a bit easier for everybody to read and see what's going on, I'm just going to reset and use this particular terminal. So first, let's remove the old Besu. If I ls right now, I see that the target is in the zip file. I can unzip Besu here. I can move inside Besu. If I come on here, I can then see in my instructions for the workshop that we're creating a contract that's using this new F6 shared secrets operation, and that creates this bytecode. And now we're going to want to wrap that contract to deploy it as an actual code that runs. So to do that, we're going to load it as the result of the execution of the transaction that creates the contract. We're going to start Besu. Start Besu, we run it with a very specific Genesis file. That is worthy of our attention here. So under the extend folder, if I do cat genesis.json, I can see that we have a workshop block of 0. That's our own hard fork. At the 0 block, we're actually changing the way, the behavior of the chain to use our workshop approach. We're also using some known accounts. If you notice, they actually are a copy of what was in dev.json. And we're using a fixed difficulty, so we can actually build and mine our own blocks using a very low difficulty here. So now we're running Besu in here. So let's take a look. we're running Besu with orgenesis.json. We're enabling HTTP. We're saying it's okay to use it with localhost and this is getting too big. Localhost and MetaMask, and we're going to use our hidden CLI argument. The quick brown fox is going to be set by default. We're also enabling ourselves to mine over CPU, and then we're going to use a miner Coinbase of a node account. Okay. No existing database. We're starting off fresh, which is brand new, and you can see Besu is already starting to produce its own logs. Okay, now going back to our instructions, we're going to deploy a contract. A contract is, right here, and we want to create. Oh, sorry, we want to first sign it so that we can sign the transaction to deploy. So let's go to our Besu workshop, and workshop. And on this, I have a little bit of a reverse.js code that takes our contract, uses our private key for a particular account that is actually listed in the genesis.json, and then generates a EIP 1559 compatible transactions, signs it, and outputs its transaction hash and its signed transaction. So if I do node deploy.js, you'll see that I have a signed transaction here, which is this lengthy chunk of hex. And then I have the hash that I should expect out of that here. Now I'm going to take this signed transaction hash. Let's take a look here at here, in here, and then I go to my README, for example. So we're going to deploy the contract. I'm going to copy this. I'm going to paste it in here. And I'm going to copy this content and curl it using the send raw transaction to our local Besu. Get a result. The result is the hash, and the hash matches what we expected, which is great. Now we can get the receipt that actually matches the transaction itself, so we can see what has been done. Oh, sorry, wrong transaction hash. So now we get that, and that gets us a contract address that we can use to work with this particular contract. Let's make sure it's been deployed properly. Okay, we can see there's some code in here, and it does match what I would expect to see. There's more F6 bytecode being generated. And now we can call the contract. So we're going to call the contract, and we're going to call it without any, any arguments, no data whatsoever. When we do that, we get a result of 0x00. Interesting. Now let's do that, but this time we're going to take the hash of the quick brown fox. So trust me on that one. That's the correct hash. I can show you how to do it yourself. I get a result of 0x01. Excellent. Now, I'm not sure this is all working correctly, so let's change the shared secret. I'm going to pass in params of the hash of Besu is awesome. Okay. Success. Great. Let's try it again. But the hash of Besu is awesome is 0xe2544, blah, 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 right? Let's use it with the old hash first. I got 0 now. Oh no. Is this changed properly? Yeah, I know what's happening. I need to change the contract address every time. Now I can curl for that and call it, and it returns 1. So here we go. We're able to extend Besu, create our own opcode. All the code of this is in the workshop branch under my fork, and I'll make that available to you so you can play. any questions, any shock or interpretation, anything you'd like to know that we've been learning through this. See, that's hard, right? You can extend Besu anytime you like. You can create your own app codes, and you can make them part of it, and you can even map them to the rest of the clients, so you can extend it very meaningfully. Anything I missed? Anything I glossed over in the last 2 minutes we have at our disposal? We're getting a question in Discord. This was great. Thank you. I really appreciate that, more than you know.
Yeah, that's great to hear. I'm glad this was really helpful for people. And thank you, Antoine. This is, yeah, really nice, and it's going to live on. This will be, as soon as this is over, it will show up on the YouTube channel, so it will be a resource people can check out, going forward. So thank you for doing this.
You're very welcome. I would wonder, like, was it useful to see code? Was it useful to see me type away? Okay, you got lost during the plumbing, yeah. There's definitely going to be a replay available as soon as it's done here.
Yeah, let me grab the link.
Yeah, we'll be on YouTube, and I'm available. If you have questions, I'm on Discord, and you can you go to the Besu workshop channel. You can keep asking questions there. How can I get help to deploy on premise? Well, there are multiple companies out there that actually provide professional support and help when it comes to Besu support. I believe that they're listed in contributors or as part of the Besu website. You can also ask questions on the Besu channel on Discord, and we'd be happy to help you on a best effort basis. So it's all depending on what type of help, what are you looking for. Exactly, David, thank you. Yeah, the vendor directory you can go and peruse, and many partners have been playing with Besu as a thing to deploy. I would not get myself involved too much in supporting people in pod. I'm just not that person.
And Antoine, I need to drop here in a minute, but thank you again. And yeah, for everybody who joined, yeah, feel free to watch the replay. Hopefully that's a useful resource. And as we've been saying, that Discord, the Zoom channel will go away as soon as this is over, but the Discord channel remains. So join us there, and let's keep the conversation going.
Thanks a lot. It was first time for me doing 4 hours. Hopefully you took away from this, and I look forward to meeting all of you one day.
Great. Thanks, everyone.
Thank you.
Bye.